Hello everyone and welcome to Microsoft's Designing and Implementing Enterprise Scale Analytics Solutions using Microsoft Azure and Microsoft Power BI. My name is Anna, and in this video we will speak about the course prerequisites and outline. We will see the agenda for this module, and of course we will get introduced to some of the terms that will be covered throughout this course later on. In this course, we will be speaking about solutions such as Azure Synapse Analytics, Microsoft Power BI, Microsoft Purview, and many others. So without any further ado, let's get started with some course introduction. In the recent years, enterprises have faced the digital transformation, which has led to an explosion of data sources that are being used in everyday BI reporting, that are being used by data analysts, data engineers, and many other data professionals. This multitude of sources needs very frequently to be unified in a single source of truth, such as, for example, an Azure Data Lake storage account or a massively parallel processing engine in Azure Synapse Analytics, which will provide the data warehouse, the modern data warehouse of our solution, in order to be later on used as the basis for our BI reports in Power BI. So in this training, we're going to be focusing on these huge amounts of data and how we should optimize that data ingestion, transformation, in order to later on leverage that in BI reporting on an enterprise scale. And when we refer to the enterprise scale, we're working with petabytes of data. We're working with billions of rows in our single table. And that's why we need to make sure that our solution is scalable and optimal. It can handle that load. So let's have a look at the enterprise data analyst role, and let's understand what are the main responsibilities of the enterprise data analyst. An enterprise data analyst will typically deal with big amounts of data that needs first to be ingested into a single source of truth. They will be typically dealing with cleaning that data, creating different tables, making a homogeneous, unified single source of truth. Once that is done, they will be leveraging tools like Power BI in order to provide enterprise-level reporting. And in this training, we will be focusing on the tools that this specialty will be using. For example, T-SQL scripts in order to ingest the data and transform it in Azure Synapse Analytics. We will be using a little bit of PySpark in Apache Spark clusters in Azure Synapse Analytics. And once we will have seen how you can create that single source of truth, leveraging those different clusters, different offerings in Azure Synapse Analytics, we will then see how you should optimize your solution in Power BI, how you should build your tabular data model, how you should optimize that tabular data model, what storage mode you should be using for your tabular data model, and many other optimization techniques. We will also touch on different techniques such as licensing. What type of licensing should you go for when we are speaking about enterprise scale level? And once we would have seen that, we will also touch on topics like enterprise data governance with Microsoft Purview, which is a product which will let you govern the data across the enterprise, make sure that your data is compliant to GDPR requirements, and much more. So now that we have seen what a data analyst on an enterprise scale role deals with, let's have a look at a little bit at our prerequisites for the course. So for the course prerequisites, we would expect you to be speaking about, to be familiar with foundational knowledge of data concepts. For example, what are the types of data, structured, unstructured, etc. And these topics are covered in other courses such as DP-500, so you can use Microsoft Learning Paths, for example, to ramp up on that stuff if you're not very familiar with this. Another aspect that we would expect you to be familiar with and comfortable with would be the essential knowledge of Power BI, such as creating data reports. What is DAX, the data analysis expressions, how to use them? Because in this training, we're not really focusing on how to create a report, but more how to optimize your data sets, how to optimize your solution for enterprise scale solution. So let's have a look at what we will learn in this training. As you can see from the slide, we will first be focusing on querying and transforming the data, because as a data analyst on an enterprise scale, most probably you will have to bring the data into some single source of truth, which will later on be used for your reports in Power BI. And in order to do that, you could use tools such as Azure Synapse Analytics, because it's a product that will let you use different clusters such as SQL dedicated pool, SQL serverless pool, or Apache Spark clusters. And those different offerings will enable you bring your data into one single place independently of what type of data you're working with. Structured, unstructured, be it online e-commerce data sets, be it online data coming from CRMs and BI type of systems where we're dealing mostly with structured data types. And we will be looking into how you can leverage those clusters, what scripts you could write. We will have some exercises and labs on that stuff. We will then learn how you can implement and manage your data models. And when we're speaking about data models, we're mostly talking about how you should build and design your tabular data model in Power BI. And it's very important when we're talking about petabytes of data, when we're talking about large tables. Because imagine that your BI report users, the consumers of your reports, will be loading a report, updating some visuals, refreshing them, and their visuals are taking eternity to load. And that's something that can happen if your tabular data is not designed properly behind the scenes in Power BI, or the data source itself is not optimized. So in this training, we will learn those techniques that will let you design that tabular model in Power BI in such a way that you will be able to provide a solution that is scalable. We will then speak about exploring and visualizing data, and again, there our goal is mostly to focus on optimization techniques, how you should design visuals that are friendly for color-blinded people, that visuals that will look professional. So that is going to be the main focus in the visualization portion of this course. And finally, we will speak about implementing and managing a data analytics environment, which means that we will speak about topics like how you should optimize your solution to provide CI/CD pipelines, how you should create automated tasks such as provisioning of your Power BI environment, how you should maintain that ecosystem in a more optimal way. So let's now talk about the course outline and the modules in slightly more details. In Module 1, we will be talking about Introduction to Data Analytics on Azure, and actually this is Module 1, so we will be looking into different terminologies. Some of you will be already familiar with those terms, and we'll just recap them. And we will also see a couple of screenshots that show an end-to-end solution that has already been deployed. We will then speak about, in Module 2, about governing data across an enterprise. And that will be the portion where we speak about Microsoft Purview. We will understand how that service will enable you in governing your data across an enterprise so that your data analysts, data engineers, and even the end users, the BI consumers, will be able to visualize the end-to-end lifecycle of your data, the lineage of your data. Where is it coming from? How many sources you have? And we'll see how we can set up our, Microsoft Purview in order to achieve that. We will then go into Module 3, where we will understand Azure Synapse Analytics and how you can leverage that solution in order to build your single source of truth within an enterprise. And when we speak about that single source of truth, we refer to either a massively parallel processing data warehouse portion of Synapse Analytics, so that will be the modern data warehouse leveraging the dedicated SQL pool. Or that could be Apache PySpark clusters, which you will leverage in order to ingest big amounts and big volumes of enterprise data. That could be unstructured data, semi-structured data that is coming from big data type of processing, and you will then leverage that data in order to push that into your dedicated SQL pool, for example. After Module 3, we will look into Module 4, where we will understand how you can build your tabular model in Power BI, and more specifically, we will understand why is it important to use the star schema, especially when we talk about enterprise scale data sets, how we should design our tabular model using the star schema, and we will also speak a little bit about the different aspects of Power BI, which will let you optimize the storage mode for the enterprise scale. We will then continue with Module 5, where we will understand how you can design and build tabular models, and more specifically, we will be focusing how we should design filters and the directions in the cross-filter directions within our tabular model. That is to say, how should your filter travel throughout the DAX expression execution behind the scenes? Then we will also touch on topics like object level security and row level security in Module 5, so we have quite a lot to cover there. In Module 6, we will speak about advanced data visualizations. And there we will be talking about how you could improve your visuals for enterprise scale reporting. That means that your end users need to be sure that the report is professional, they need to be using that report, and we will focus on more of the visual aspects about that. In Module 7, we will be speaking about implementing and managing an analytics environment, and that's a big module. It's going to be split into 2 parts, and we will be speaking about how you can leverage the administrative tasks using some automation tools in Power BI. We will also talk about 3 different stakeholder types that you typically would have in any Power BI ecosystem, and what are the main responsibilities of those roles, of those different experts involved in that roles. And finally, in Module 8, we will speak about managing the analytics development lifecycle, where we will mostly focus on the CI/CD pipelines within the Power BI environment and how you can automate those tasks within Power BI and ensure that your data engineering teams and data analyst teams are collaborating on the report creation and how can they see what others are doing. So that's our course outline, and let's now look into the module agenda for this specific module. So first we will be talking about generic terms. That will be a recap for some of you because you might already be familiar with those terms. So we will just go over those definitions and understand what are the different aspects of enterprise scale data analytics. In Lesson 2, we will speak about concepts of data analytics. We will speak about the different roles within an enterprise that are involved with data analytics. And then finally, in Lesson 3, we will speak about exploring data analytics at scale, which means that we will see a couple of screenshots, a couple of examples of how your end-to-end solution will look like once it's configured. So let's get started with some introduction to data analytics on Azure, and more specifically, Lesson 1 of our Module 1. With this era of data as a currency, enterprises are looking for making their decisions based on data, and they look into getting insights from their data and make those data-driven decisions be as optimal as possible. And for that reason, we will first have a look at the different aspects of data storage, data ecosystem that you might be dealing with as a data analyst on an enterprise scale. And we'll understand on a higher level what are the different sources from where we can get the data and different architectures. So as you can see from this slide here, we have our different data sources, which could be sources on-prem environments, those could be sources from in cloud environments, cloud-based sources, and we need to first of all ingest that data. And within an ecosystem of our data analytics environment, we first will be thinking about where are we going to store that data. And that data storage could be cloud-based storage such as Azure Data Lake storage account. That could be a data warehouse that we will be building later on. And once we have decided for the data storage, we might also have a portion of data that will be ingested in real time. So real-time ingestion, we'll be mostly dealing with getting the data in real time, transforming it also as the data arrives, and again, we will need to store that data somewhere. That's why we have this arrow connecting that to the data storage here. And in terms of the data processing, when we will need to transform that data, for example, we might want to remove some columns that are not needed, or we might want to improve our data sets. So when we do that, that processing, ETL, ELT processing, is going to involve either batch processing that we see here on the top of the slide, or it could be the stream processing, because for streaming data, we need to transform that in real time. And there will be different environments, different services that will let us do that transformation of the data. And typically different architectures depending also on whether you are dealing only with batch processing data or only with stream processing or both. And in some cases, you might want to involve also machine learning services, for example, Azure Machine Learning Service, which will improve your data and predict what, for example, would be the sales amounts in 2023 based on what we sold so far in 2021. And that machine learning enhanced data will be also stored somewhere. It might be also get reprocessed. And finally, it will be serving for our analytical data store, which we see in here, and it will be used for our enterprise level reporting. For example, your BI stakeholders might want to know how much sales we will do in the next year based on what has been sold so far. Those could be also some predictions for financial systems, etc. And then we will be using our reporting system, which could be Power BI. Let's have a look at the next slide, where we will see an end-to-end solution that has been already set up. So what we are facing on this slide, on the left-hand side, we are seeing the different hubs and different sections of Azure Synapse Analytics, which has already been set up. On the Azure Synapse Analytics page in the Develop Hub, in which we are currently situated, you will see that we have opened up the Power BI section, where we see directly our Power BI reports and dashboards, and they are displayed on the canvas on the right-hand side. And this is an example of how you could involve both of those solutions to build an end-to-end system and even visualize your Power BI dashboards and reports from Azure Synapse Analytics. And typically, when we deal with enterprise-scale data sets, we're no longer speaking about only BI reporting, but we also speak about enterprise-level analytics, which involves also the Azure Synapse Analytics service as our data warehouse behind the scenes. So now let's have a look at some definitions. And in Lesson 2, we will speak about concepts of data analytics, what are the different profiles that deal with data analytics in an enterprise, and we will understand what are their roles and responsibilities. So when we speak about data analysis types, data analytics, we will be talking about 5 major groups. So there is the descriptive analytics, the diagnostic analytics, predictive analytics, prescriptive, and cognitive. So with descriptive analytics, we're usually describing what happened in a system. For example, we might be describing how much sales we did in 2022, or we might be describing what's the current state of our financial market. We might be describing what's the current state of our patients if it's for more of a medical application, and so on. With diagnostic analytics, we're mostly understanding why things happened. For example, if we had a call center, and in that call center we had too many phone calls, and we might be trying to understand why the customers weren't so happy about their calls not being taken. We might want to look into some logs. Maybe there weren't enough operators available. Maybe there weren't enough servers available. So that's the type of diagnostic analytics where we explain the why. In predictive analytics, we're going to be describing the what will happen. So with predictive one, we usually leverage services like Azure Machine Learning, for example, or any other machine learning technologies that will predict the probability, the likelihood of something happening in the future, given the set of observations we had so far. For example, we could be predicting or understanding if somebody has diabetes based on their different parameters, medical parameters that we already had so far and the previous observations. And in those cases, we need to train our machine learning algorithm and then use that model that will be used later on for predictions in real time or in batches. In prescriptive analytics, we're going to be taking the predictive analytics one step further, and we will be trying to suggest what the user or what the stakeholder, that could be a BI user or any other stakeholder, do based on what we know will happen, what is the most likely thing to happen based on our observations. An example of a prescriptive analytics would be, for example, when you are logging into some of your movie portals where you're watching movies, service providers, and you are being suggested some of the movies based on what you have been watching so far, movies, series, name it. And finally, the cognitive analytics that combines artificial intelligence, different skill sets which we can use to enhance our data sets. For example, we could create a search engine that is using some AI skills in order to search throughout our website. And in the meantime, if I'm making that search, let's say from France, it's going to translate the text also in French, and it will basically improve my data sets, my data that I'm dealing with in that search solution. And for cognitive type of analytics, we typically use services like AI cognitive services on Azure, for instance. In terms of the data analysis process, we will be always starting with requirements gathering. Before jumping into the design, into scaling and all that stuff, we need to understand what are the requirements, what problem are we trying to solve, what are our BI stakeholders or report consumers asking as questions. Are they trying to predict something? Are they trying to prescribe some solutions, or just describe the system in their current state and get into the details of what is needed? So the requirements gathering will always be the first portion where we start. We will then need to ingest the data and process that. So we'll need to first make sure that we are building our single source of truth, and for that we need to start with connecting to the data sources and ingesting them. We'll then need to explore our data to qualify that, quantify that, and once that is done, we will then be able to go into the data analysis phase. Finally, when the data analysis is done, we will go into data analytics solution deployment, where we will operationalize the workloads that we're working with. And then we will ask our users for feedback. And those feedbacks could be feedbacks on the reports, on the way the solution is performing. Is it fast enough? Are the reports updating nicely, smoothly? Are we getting the answers to the questions that we want to answer in terms of our BI type of analysis or not? And once we got the feedback from our BI stakeholders, from our report consumers, we'll need to optimize our solution, and then we'll feed this into the requirements gathering again, and this is a continuous life cycle that we'll be using. Let's go into the next slide, where we will see what are the data storage types and the data types. So as you might already know, we have the structured data types, unstructured ones, and semi-structured ones. The structured data is usually the one that is describing some kind of relationship between tables, so it's organized into rows and columns. Usually those are tables that have fixed relationships between them. And those type of data sets, examples of those kind of data sets could be, for example, some CRMs, some data sets that are using an existing on-premise data warehouse that you need to migrate into the cloud. In unstructured data, we're mostly focusing on the data that is not having any specific relationships, and it doesn't have a specific structure. So it's not really organized into rows or columns. And those kind of data sets, those could be some movie files, those could be some social media files. And that kind of data needs a storage that is more similar to data lake, Azure Data Lake storage account, for example. For structured data, on the contrary, we will be using mostly relational databases in the cloud or on-prem environments, or data warehouses. Synapse Analytics dedicated SQL pool in this example. So now let's talk about lesson 3, where we will understand what are the options to explore our data analysis at scale, and what are the different roles within an organization that deal with data. So as you can see from the slide here, we have different profiles. We have a data analyst, we will have typically also a database administrator, we have data engineer, data scientist, and data architect. For a data analyst, main responsibilities are usually gathering requirements of what type of analysis we want to provide, creating reports that are scaling on an enterprise level if we are talking about enterprise scale analytics. Also gathering some kind of feedback from the users, designing the reports, designing the CI/CD pipelines for those reports. So this is mostly dealing with reports portion of things. Database administrators, on the other hand, they are mostly professionals who deal with implementing, designing solutions either on-premise environments or in the cloud, for providing database creation, database maintaining, and also granting access to database users, etc. A data engineer is a professional who is going to deal mostly with ingesting the data from external sources, creating a single source of truth, and also making sure that the data is transformed. So they are also doing the ETL, ELT transformation part of that cycle. Data scientists, those are the professionals that will be creating either using graphical tools or they will be using code in order to create some machine learning algorithms that will be predicting what will happen once we have some set of observations on different data sets. And for a data scientist, usually they are getting the data that has been ingested and prepped by a data engineer or by a team of data engineers. And quite similarly for data analysts, they are going to be mostly working in collaboration with data engineering teams in order to have that information from the massively parallel processing engine, if we are speaking about Synapse Analytics, or from any type of unified single source of truth. And finally, we have our data architects that are mostly responsible for designing an ecosystem that will be scalable and flexible. They will be also looking into infrastructure part of things on the data side. So those are mostly professionals who will deal with the design of our solution. In terms of the data analysts, the tools that they are going to be leveraging are going to be mostly tools like Azure Synapse Analytics, because we are talking about enterprise scale data analytics. We are talking about Power BI, so that's another tool that is going to be used quite a lot. And Purview, which is a tool which will provide you data governance techniques for your entire data ecosystem. Of course, in the Power BI local environment as well, there will be some portion of data governance that you can deploy and implement, but Microsoft Purview is going to provide you the whole entire solution for the ecosystem of different components that you have within your enterprise environment. And as you can see on the slide, we have mentioned a couple of tasks that a data analyst will be doing. So that's mostly collecting and cleansing our data and bringing it into Synapse Analytics. Then it will be dealing with ingesting and transforming that data once it has been brought into Synapse Analytics or into our data lake storage account. And once that is done, we will be creating our tabular model. So we design it first, then we create the relationships between the tables, and then we provide our reports. We create the reports at the enterprise scale. And of course, Purview will help us govern all that ecosystem and help the end users and also data professionals understand where that data sources are coming from within their ecosystem. As an example, on this slide, we have an end-to-end solution again taken further. So as you can see, we have some unification with Synapse Analytics and Power BI. We can visualize our reports, and within the Develop Hub, you can see the list of different SQL scripts that we can directly access from this environment. We can access our notebooks, and we can also see some Power BI aspects of development that we can do directly from Synapse Analytics. So they are natively integrated, and we're going to be discovering those aspects throughout the course. And finally, a very important process within the data ecosystem design and creation is that you need also to establish a data culture. You need to make sure that you have a center of excellence where you will be providing your users with the policies and with rules how your data should be used within the enterprise, where it should be stored. And that data culture is also a very important aspect of a healthy data ecosystem, which is especially on an enterprise scale. And you can also build a community of practice, how you can use that data sets, where the data is coming from, what's the governance strategy from data. So those are techniques that are more focusing on people and the process, but they are very important in having a healthy ecosystem on the data side of things. In Module 1, we learned about the different terminologies that will be used later on throughout this course. We understood what are the services that we will be working with in most of the labs and what we will be learning in this training. And we also had a little overview of an end-to-end solution with Azure Synapse Analytics and Power BI, which we will be developing later on in later modules of this course. I hope to see you in the next videos. I hope you enjoyed it. And of course, don't forget about the knowledge check. Thank you everybody for listening, and see you later. So let's see the knowledge check for Module 1. Are you ready? Question 1. What type of data is best suited for batch processing? Daily sales report data, IoT gas sensor data that monitors and detects the presence of toxic or hazardous gases, or real-time personalized advertising data? That's right. Daily sales report data is the correct answer, and it's the best suited for batch processing because the other two are better suited for real-time processing. Question 2. Which of the following is an example of descriptive analytics? A social media algorithm that recommends curated content, a monthly sales report looking at sales data over the last year, or an annual HR report that forecasts predicted attrition for the next year. And the right answer is a monthly sales report looking at sales data over the last year. Question 3. What are the first 3 steps in the data analysis process? Data exploration, data analysis, and deploy analytics solution, requirements gathering, data ingestion and processing, and data exploration, or data analysis, deploy an analytics solution, and request feedback. And the correct answer is, of course, we need to start with requirements gathering. Remember the life cycle of the analysis solution that we saw earlier. Question 4. Why is it important to understand the difference between structured and unstructured data? There is no difference between structured and unstructured data. Understanding the difference will determine if the business requirements have been met. Or understanding the difference can determine where data should be stored and what kind of analysis is most appropriate. And of course, the correct answer is answer 3. Question 5. What Microsoft tools do data analysts use for enterprise-scale analytics solutions? Azure Machine Learning and Azure Cosmos DB, Azure Synapse Analytics and Microsoft Power BI, or Microsoft Excel. And of course, the right answer is Azure Synapse Analytics and Microsoft Power BI, because those are going to provide enterprise-scale analytics using some data warehousing tools and reporting for Microsoft Power BI. And that was the end of our knowledge check. I hope you enjoyed it, and see you in next sections. Hello everyone, and welcome to Microsoft's Designing and Implementing Enterprise-Scale Analytics Solutions using Microsoft Azure and Microsoft Power BI. My name is Anna. This is DP-500 Module 2, Govern Data Across an Enterprise. And in this module, we will be looking into Microsoft Purview, which is a solution that will let you govern your data across an enterprise, understand what are the different data sources that you're dealing with, what is the data lineage, and all the stakeholders that will have access to Microsoft Purview can see that data lineage throughout the company. It will also let you be compliant to GDPR by labeling data as sensitive data assets and knowing what are the sensitive data assets across your enterprise. So let's get started with some module agenda. In this module, we will first understand Microsoft Purview main components. We will see the design of Microsoft Purview, how are the different parts of Microsoft Purview communicating with each other, and then we will understand in lessons 2 and 3 how you can create and hydrate your data map, and consequently, once that data map is created, in lesson 3 we will see how you can search the catalog or browse the catalog of your Microsoft Purview tenant. And then we will see in the last portion of this module, in lesson 4, we will understand how Power BI assets can be also cataloged in Microsoft Purview and how you can view them and see what are the data sources for your Microsoft Power BI environment. So let's get started with lesson 1 with some introduction to Microsoft Purview. So let's suppose you are a consumer or a producer of data and you are using the different data sources within an enterprise. You may be a technical user, you may be a business analyst, a data analyst, or even a data engineer. Do you know what are the different data sources that you have within your enterprise? Do you know where are those data sources coming from? Do you know what's the lineage, meaning that do you know what the ETL transformations that your data is facing are happening before you get that data? And when we are talking about enterprise scale data sets, that kind of information can get lost because you might not really know what are the different data sources. And with Microsoft Purview, you will basically be able to see what are those data sources. So let's have a look at Microsoft Purview Governance Portal overview and the main components that we have within Microsoft Purview. As you can see from this slide, we have our data map, which needs to be set up and hydrated. And that essentially means that within our Microsoft Purview tenant, we will need to configure the different data sources and connect to them. And connecting to those sources means that you will also need to make sure that the user has access, the Microsoft Purview user will be able to connect to your data source and overview the metadata. And when we are connecting to those data sources, we will never move the data into Microsoft Purview. We will just have an overview where that data is coming from, what type of tables, for example, that data contains if we are talking about a Azure SQL data source, if we are talking about Azure Synapse Analytics data source. And as you can see on the left-hand side, the types of data sources could be various. So you can have on-premises data sources, such as a SQL database that is in an on-premise environment. You could have cloud-based applications and services. And once you are hydrating your data map, which means that you connected to the source, you made a scan, you instantiated the scan of your data source, you will be able to see what are the different components that you have within that data source. Other components that we see here are divided in terms of their utilization. For example, on the left-hand side, we have the data producers and consumers. On the right-hand side of the slide, we have the data officers. So some of the components are going to be mostly used by some of the stakeholders, such as data producers and consumers, who could be data analysts, data engineers, data scientists, and those stakeholders are going to be mostly interested to see the data catalog. So when we say see the data catalog, we mean we will be browsing the different data assets that we have within our environment. For example, I might be a data engineer that is interested to know what are the different SQL databases that we are ingesting the data from. Do those SQL databases face some ETL transformation before we use them in other tools? And that type of information will be more in data catalog. Data sharing, as you can notice from the slide, is in gray because it's a preview feature. It's a brand new feature that will let your different stakeholders share the data sets, the data asset collection that you have created. So for example, if I want my colleague to have a look at the different data assets that we have within our organization, I will invite him to my sharing, and he or she will be able to see the different data assets that we have within the organization. And again, just to emphasize that we will never move the data from its original data location. We will just connect to using metadata, and we will just connect to that data source to know what are the different data assets. We will not be moving or copying the data into Microsoft Purview. The second type of stakeholders that we see on the slide here are, as you can see, the data officers. And for them, it's going to be more useful to see the data estate insights, to understand what type of data we're dealing with, how the users, the stakeholders, data analysts, data engineers, report consumers, how they are using those data assets. And finally, we have also the data policies, which are, again, mostly used by data chief officers that will be enforcing different policies to comply to GDPR requirements, and maybe seeing what are the sensitive labels within our data sets that we're working with. And as you can see, we can work with different types of services on Azure when we're working with Purview. Now let's have a look at how Microsoft Purview works, which means once I understand what it does, how do I configure it? So here we have grouped the 3 steps, major steps, that will let you configure and connect to your Microsoft Purview account. Once you have provisioned the Microsoft Purview resource and you have connected to that, which means you have access to that resource, you will need to register your data sources. What does that mean? Well, that means that we need to instantiate a connection to our data source, which means that behind the scenes, maybe your IT teams or DevOps teams that can be different across organizations, they have set up the connection to make sure that the Microsoft Purview account can communicate with those sources, that it has the right to view metadata and data assets. Once our data source has been registered, and as an example there, we could have Azure Synapse Analytics or Azure SQL or Cosmos DB, which is our NoSQL database offering. So once we register that source, we can then scan that data source and then classify the data. We can even set up some rules in terms of the data classification. As you can see here in this global data lake, which means that in this example, we consider that we scanned a global data lake, we connected to that data source, so to a data lake storage account, basically. And once we have that connection established, we can click on this button that is underlined in red in this slide. And once we click on this button, we will be able to scan that data lake storage account, and we will see all the components that are stored in that data lake storage account. We will not be able to access to the data itself. We will just see the list of the containers, the list of folders, the list of files, but we will not be able to actually see the contents because we are not copying the data into the Microsoft Purview account. So once our data map has been hydrated and created, we can then view our data map. And as you can see on the slide from the Microsoft Purview governance portal, you will be able to see these different data sources that we have connected to, and we see our data map. For example, this first one here is a Cosmos DB. We can see, if we go into details, we will be able to see a bit more information about that data source. And we can also create some collections, which we are going to speak about in a couple of moments. So that's how Microsoft Purview configuration works in generic terms. Now, let's see how Microsoft Purview works once the data map has been created and hydrated. Now, what does that mean? Let's have a look at the slide. So as you can see in the slide, we have the screenshot from Microsoft Purview Studio. And in the studio, from the main page, we will be able to type in the keywords that we are looking for. And here we are looking for product sales, which means that we are interested in any data source across our organization that might contain information about product sales. So I might be a data analyst on an enterprise scale or a data engineer, and I want to see how many SQL tables do we have about product sales. Maybe we have some tables in NoSQL databases such as Cosmos DB. Maybe we have some tables in Azure SQL, and I might not be aware of those data sources. But with Purview, I will be able to search for the keywords that I'm interested in. And if there are any data sources that have been added to my data map, and my data map has been hydrated beforehand, I will be able to search the catalog. So when we say search the catalog of Microsoft Purview, that's what we are referring to, the ability to scan to see what are the different data assets that we have once the data map has been hydrated. Among the other sections that we see on the slide, on the screenshot, on the left-hand side, there's different hubs. We are going to look into them in more details later on, but overall you will be able to browse all these different sections from the portal. So once we have searched for the keywords that we are interested in, we're going to be able to see here, for example, that we have a report table, which is called report table _prod. And this is a certified data source, which means that it has been labeled as a trusted source of data for our organization. And in here, we can see from the little icon, we can guess that it's a Azure SQL table, and it also says that right underneath the name of our data source. On the left-hand side, we have the different filters that will let us refine our search. For example, if we're only looking for some tables, we can check this box and make sure that we will only see some SQL tables in here in the list. Now, you might be wondering, I understand what is Microsoft Purview, but when do I use that? Do I really need that? And to answer that question, let's take a moment having a look at this slide. So if you need to understand, if you do not have a single space where you would see all the data sources that you have within your organization, and you need that for your different data stakeholders, those could be data engineers, data analysts, those could be final users that are using report consumers basically. You might want to use Microsoft Purview because it gives you an overall view of your data ecosystem. If you need also some data governance, maybe you have some data chief officers that are dealing with sensitive data, they need to make sure that across your organization, your entire data sets that you are working with, data sources, they are compliant to GDPR or some local data regulations that might vary across countries. In those cases, you might again go for Microsoft Purview because it's going to let you see, let you label the data sets depending on their sensitivities, and then you will be able also to establish some policies for governing your data. So that's about a generic introduction of Microsoft Purview. Let's look into lesson 2, where we will understand how we can discover the trusted data sources using Microsoft Purview. And what does that mean? Well, that means that we will see how we can hydrate our data map and what are the different actions we need to take to search for data assets and then later on hydrate our data map. So let's imagine we're data analysts and we are looking for data assets. We want to know what are the different data sources that we have out there. And for this example, for this slide screenshot, we imagine that in our use case, the data map has been already set up and configured. And that setup can be done either by some data teams, those could be sometimes the IT teams. Usually it's a collaborative work because you also need to have access or configure the access to those different data sources. So you need to make sure that RBACs are configured in the background, for example. And you can search for more documentation if you are really looking into how to configure that on docs.microsoft.com, where you will be able to see the different aspects of configuring depending on the data source that you want to connect to. So once we have configured that data map and hydrated that, as a data analyst, I'm going to simply connect to my Microsoft Purview portal, and within that portal, as you can see here on the top hand side here, top section of the slide, screenshot, you will see that we searched for product sales, and we have been brought all these different results. You can see that some of the assets are Power BI data sets, some of the assets are CSV files. And basically, it's just searching for those keywords that we typed in the search bar that you see on the top of the section of the screenshot. On the left-hand side, we can also refine our search. And once we click on that data source that is of interest, for example, if I click on this CSV product mix files data set, we will be able to see the lineage and more information about the columns, the data types within that specific data set. So let's have a look at how we can see our different asset details. In this example, we are looking into our report table underscore prod that we saw earlier, which was an Azure SQL table, as you might remember. And when you click to see more information about that data asset, you will notice that you will have different tabs. And in this slide, we made a screenshot of the overview tab, where you can see that this specific data set, this Azure SQL table, has been labeled with some classifications. We have some schema classifications, and we can then search in the other tabs a bit more information about the schema, for example, for this data asset. So here we're in the schema tab, and in the schema tab you can see that we have the column names, we have the classifications that were used, the rules which are tagging our columns, so it understood that here in the card number field, in that column, we have credit card information. And then consequently, you can define some policies that will, for example, restrict the usage of that column. We have some country column here, which also has been detected with classification rules that it's a country, region type of data set column, etc. And finally, another important aspect of our data sets is to see the data lineage. What does the data lineage mean? It means that we want to see where the data is coming from and what type of transformations it's facing before arriving into, let's say, a Power BI data set or into a Power BI dashboard, into a Power BI report. And that can help, for example, our data analysts on an enterprise scale to know how they should design, for example, a tabular model, how they should maybe collaborate with the data engineering teams to improve the transformations that are being done closer to the source, and they will know what's the source of that data set, how they should do that transformation. And in this specific example on the slide, we can see the full lineage of our data sets. We can see where it's coming from before ending up inside this Azure SQL table. As you can see, some of them are CSV files, so we have different types of data sets that are then transformed into an Azure SQL table, and we can see later on how they are going into our Power BI dashboards and data sets. In order to see who are the stakeholders within our organization that are responsible for that data set, we can actually go into this contact section, in contacts tab within our data set. And in here, we can see that there are 2 experts associated with this data set, and there are 2 owners. So the experts are going to be typically, that could be data engineers, for example, that we can contact and maybe ask them questions about how the transformation is done or collaborate together for our common tasks. Another way to view what are your data assets is browsing for your data assets inside your data catalog. And again, the assumption here is that your data map has been created beforehand and hydrated. Now, in order to browse your assets, as you can see on the slide, if we take a moment looking at this red underlined section here, you can see that we're searching by source type, we're browsing by source type. We simply are able here to select the type of the source that we're interested in, for example, Azure Cosmos DB, or in here we have selected Azure SQL database, and we can see the list of different tables within that Azure SQL database, and on the left-hand side we see the different schemas that exist within that Azure SQL database. So if we summarize the previous couple of slides, we can either browse our catalog by browsing it directly from the portal, or we can search for data again directly from the Microsoft Purview portal. And if, let's say, you need to get access to some specific data source, there's even this button available directly from the portal that will enable you a request access directly from Microsoft Purview. So for example, if you need some access to this Azure SQL database, instead of finding the person who is in charge of that, etc., you can just go from Microsoft Purview into this request access button, click on that, and you will ask, the stakeholder will be informed that you need some access to that data set. Another important benefit in the enterprise scale data analytics context from Microsoft Purview is that you can enable the integration with Azure Synapse Analytics, which has been made for you so that you can browse your Azure from within Azure Synapse Analytics. You can browse Microsoft Purview assets, interact with them, so you don't really need to switch between those interfaces that are 2 different studios. We have the Synapse Studio, and we have the Azure Synapse Analytics Studio, and we have also the Microsoft Purview Studio. So if you don't want to switch between those 2 interfaces, you might want to directly use that integration to connect to your Microsoft Purview account directly from Azure Synapse Analytics. But please keep in mind that for that you will need some extra configurations in terms of the RBACs. So we have that documentation available in case if you are configuring this portion of things. Now let's have a look at how we can catalog our data artifacts using Microsoft Purview. And when we speak about cataloging data artifacts, we're referring to hydrating our data map. So in order to do that, we will need to create collections. We don't have to, but let's imagine we have a company where we have sales team, marketing team, and many other teams. And when we want to add different data sources, when we want to visualize our entire data ecosystem with a data map, we might want to specify also before we do the scan, before we register the sources, etc. We might want to see what are the departments that are using that data sets, or logically to which departments those data sources belong to. And in that case, we can create collections. By default, in Microsoft Purview, you will have a collection that exists, and you will be scanning directly in that collection if you do not create your own different collections. But you can basically create hierarchies and say, let's say this is the sales department, this is the marketing, and when you add some data sources to scan them, you can actually specify to which collection, at which collection level they are associated. It's just a way to structure your data map. So once we have connected to our data sources, we can register them and scan them. And finally, with permissions, you will be able to grant permissions to your Microsoft Purview in order to make sure that at the collection level, you will be able to connect to those data sources and visualize the information within them. So how can we create a classification and labels within our data sets? Before seeing the how, let's understand what is classification. And in that example that we saw earlier with our Azure SQL table, we saw that we have a column that was called card number. And as you can see from this card number column, it's classified as a credit card number. So basically in Microsoft Purview, you can create rules and you can make sure that it understands what type of data is stored in that specific column. In this example, it's a column within our table, and we will see that it's a credit card number. And in a similar manner, you can also create sensitivity labels for your data so that we know that it's confidential data and we are not going to be sending it to some stakeholders that are not supposed to see that. Now let's see how we can search our data catalog. From this screenshot, we can see how we are searching our existing data catalog, which has been already created beforehand. You can see that on this left-hand side, we have the different filters that will let us refine our search. And we can see here that we can even specify filters on a more granular level in order to search for specific columns within our tables, for instance. And in the list of results, we have a couple of different databases that have been brought into our interface. And finally, if we're speaking about enterprise scale data analytics, of course, we will need to also classify the data sources that we are using in Microsoft Power BI. And due to thanks to the integration that we have between Microsoft Power BI and Microsoft Purview, in quite a similar way that we saw beforehand for other sources, you can also search your Microsoft Power BI assets and understand, for example, where does this data set in Power BI coming from? Is it coming from Azure SQL database? Is it coming from Synapse Analytics database maybe? Or is it coming from some other external sources? So you can actually visualize that thanks to that integration. And as you can see from this slide, there is nothing very different from what we saw earlier. We can simply register our sources and we can scan our Power BI assets and we will see the lineage of the data that is coming into Power BI. In order to search our Microsoft Purview data catalog for browsing for our Power BI data assets, again, you have the search option and the browse option, just in a similar way that we saw for any other type of data artifacts. And of course, we can view our lineage of the data where we will see where the data is coming from, what type of transformation it's facing before arriving into Power BI as a data set and then ending up in some dashboards and reports in Power BI. So this is our demo for Module 2, where we will be looking into Microsoft Purview Governance Portal. We're currently connected to my Microsoft Purview Governance Portal, which is named, as you can see, Purview ANA DP-500. We can see on the main page the catalog which we can search, and as you can see, I have already performed the search of a user profile keyword, which brings me up with the Cosmos DB account, where I have a user profile collection of JSON documents. On the left-hand side, we have all the different data hubs, data catalog, data map hub, data share, etc., which will let me navigate throughout my data governance portal in Microsoft Purview. We have also this subsection, which on the home page will let me go into browse by collection or browse by source type feature, which we discussed earlier in this module. If we go into our data catalog, we will be able to see also the search bar, which will let us to search again from here the different assets. And if I click on that search for user profile keyword, you will see that we're brought up with two different results, and we have both of them that belong to Azure Cosmos DB. If we click on user profile HTTP, we can see all those different tabs that we saw earlier in our slide deck for Module 2, where you will notice that we can get some overview about this data set. We will see some of the properties, the schema, the lineage. There isn't any because my data is not really coming from somewhere else. It's directly in Cosmos DB. Contacts, if there are any experts related. and some other related information. For example, in this Cosmos DB, we can see on the left-hand side, we have Azure Cosmos DB account that is called ASA Cosmos DB Lab 8, which has customer profile database within it. And underneath, we have 3 different containers. One that is called My Container, another one that is called Online User Profile 01, and another one that is called User Profile HTAB. So this user profile HTAB container is related to this customer profile database and to this Cosmos DB account. If we move on into the data map hub, we will see the data map that we have built prior to this and hydrated. What does that mean? Well, as you remember, we need to create our collections, and I do have my default root collection, which has the same name as my Microsoft Purview governance portal. And this is called Purview ANA DP-500. And underneath, I have all the different collections that are created to distinguish between different departments in the company: sales, marketing, data engineering, etc. And as you can notice, I registered my data sources at the different collection levels to visually represent and to organize my different data assets into these collections. So for example, under the sales department, I have registered an Azure Synapse Analytics workspace so to distinguish that this data source is used by sales department. And once that data source has been registered, we can scan that. However, in order to scan that data source, as you might remember, we need to make sure that behind the scenes, prior to the scan, all the different RBACs on the Azure Synapse Analytics side and on the Microsoft Purview side have to be set up so that the managed identities of those applications can speak to each other, which means that we need to have access between those two to communicate. Similarly for Cosmos DB and similarly for registering Power BI data sources and then scanning them. So let's see how we can instantiate a new scan. And here I will simply click on this new scan button. And this will create a new name for this specific scan. And as you can see, I have already beforehand created a credential for Cosmos Scan, which means that in this specific example, I'm using a key vault store behind the scenes from where I'm using the Cosmos DB account key, which is stored in that key vault store. And this credential is basically pointing to that key and saying that we have the right to use that key. And we can test also the connection here. And as you can see, the connection is successful. I will hit continue. And as you can see here, we can already distinguish what are the different entities within this Cosmos DB. I will continue to scope my scan. I will not be setting up any scan rules, although you can personalize those scan rule sets. And I will not be doing any scheduled recurring type of scans. I will just do it once. We will save and run. And once this scan instance is submitted, I can then get the information about my Cosmos DB. In the same way, if we navigate to the next sections, we will be simply able to see inside the main section of this page the different portions of our governance portal in Microsoft Purview. And as you can notice, for example, in Data Share, it's a preview feature, which, as we saw in the slides, that's something new where you can create a new instance of Share with other users. So, for example, if I would like to invite a colleague to see my collection, which is called Purview ANA DP-500, I can send an invite by clicking onto this Create a Share button. And you can notice here, if in my received shares, I do have one share that has been received from myself. I sent myself an invite, and we can see that share in here, both in the sent shares and the received shares as well. And we can click on that to get more information, to see who sent us that share and what are the different assets associated with that share. We then have the data estate insights. This is a section that is more targeting the data chief officers who would like to see what's the real data estate in their organization and what's the insights on that data estate, which of the assets are used more frequently, which of the assets are curated or not curated. So it's more on the data governance side of things. Similarly, for the data policy, it's more targeting the data stewards, but that could be in some cases also interesting for from the perspective of a data enterprise analyst. And finally, we have here the management hub, where we can do some extra configurations. For example, we can have a look at our credentials that we set up. And as you can see, that credential for Cosmos Scan is stored here, and it's pointing to a key vault store where I'm storing the key in order to connect to Cosmos DB account that is called as a Cosmos DB Lab 8. So here from the main page, we can again search different assets, for example, product, and we will be seeing all the different databases or different data assets. Those could be files as well, where we have that keyword appearing. And with that, we have reached the end for this theory for Module 3, where we learned how you can create and hydrate your data map for your data environment and visualize the data assets in your ecosystem. We learned how to browse by collection or browse by searching your keywords. And we learned also how to visualize the data asset lineage and the data assets that you have in Microsoft Power BI. And I'll see you in the knowledge check section. Let's see some knowledge check questions for Module 2. Are you ready? Question 1. What does Microsoft Purview do with the data it discovers from your registered sources? It catalogs and classifies the data that is scanned. It moves the data to your Azure subscription, automatically creating the necessary storage accounts. It performs data transformations to match your on-premises schemas. And that's right. The first answer is the right one. It catalogs and classifies the data that is scanned. We will never move the data from its original location into a storage account or into Purview. Question 2. Where would you register your data sources for use in Microsoft Purview? In the Overview tab of the Microsoft Purview account page, in the Microsoft Purview Governance portal, or in the Managed Resources tab of the Microsoft Purview account page. And the right answer is answer 2, in the Microsoft Purview Governance portal. Question 3. What aspects of Microsoft Purview is used to configure the data discovery for your data sources? Collections, scan rules, or classifications? And the right answer is collections. We discover at the collection level. Question 4. What feature of Microsoft Purview can analysts and other data consumers use to find trustworthy data for reports? Data map, data catalog, or data policies? And the right answer is, of course, data catalog. With that, we have come to the end of our knowledge check for Module 2, and I'll see you in the next videos. Thank you, everyone. Hello, everyone, and welcome to Microsoft's Designing and Implementing Enterprise-Scale Analytics Solutions using Microsoft Azure and Microsoft Power BI. I'm Anna. This is DP-500, Module 3, where we will learn how to model, query, and explore data in Azure Synapse Analytics. As the volumes of data increase significantly in most of the organizations nowadays, and organizations are trying to make more of data-driven decisions and use that data in order to measure KPIs, understand their systems, we need to provide also systems that will be scalable enough to provide the storage for that data and also provide analytics on top of that data. Azure Synapse Analytics is a tool, is a service in cloud that will let us provide both storage and also design our data warehouse in the cloud. And we will be introducing in this specific module what are the different aspects of Azure Synapse Analytics in order to work with data. So let's see the lesson included in this module. So we will first speak about Synapse Analytics and what are the main components of Azure Synapse Analytics. We will then move into understanding of Azure Synapse Analytics serverless SQL pools and how you can leverage them in order to explore your big data volumes in order to then provide some insights and a logical data warehouse on top of that. We will then speak about Apache Spark in Azure Synapse Analytics and how you can leverage those Apache Spark clusters and write PySpark or Scala or other language notebooks inside Apache Spark clusters to explore your data, and on top of that, then to save that data in the formats that are needed to enable analytics on top of that. And finally, we will speak about analyzing data in a relational data warehouse, which means that we will be talking about dedicated SQL pool in Azure Synapse Analytics, which will provide us the massively parallel processing engine for our SQL dedicated pool, that is to say, to our SQL data warehouse in the cloud. And then this data is going to be later on used in order to provide reporting in Power BI and connect to that data as Power BI data sets. So let's start with lesson 1 with a generic introduction to Azure Synapse Analytics. As you can see from the slide, Azure Synapse Analytics is going to provide us a single place, a single source, which will have different types of clusters that will enable us explore our data, transform that data. We can also ingest data from different external sources, and then we can use that data to build our data warehouse. So in terms of the components that we have in Azure Synapse Analytics, we have the SQL offering and we have the Spark offering. In terms of the SQL pools, we have two types of offerings. We have the dedicated SQL pools and the serverless SQL pools. The dedicated SQL pools is the data warehouse in the cloud portion of Azure Synapse Analytics. Now, what does that mean? That means that we can create a relational data warehouse which is distributed in terms of the storage, and the compute is separated from the storage, and it will enable us make quicker computations within our distributed data warehouse in the cloud. And technically, Azure Synapse Analytics dedicated SQL pools is the logical continuation of the SQL data warehouse on premises that you might have already be familiar with. The other offering that we have on the slide here, the serverless SQL pools, that's the portion of Azure Synapse Analytics that will enable us use our serverless SQL pool on scalable on-demand compute in order to explore our data sets that we have in the Azure Data Lake storage account, for example. So basically, you can connect using the serverless SQL pools to your data sets. Those could be CSV files, Parquet files, and we're going to discuss that in more details later on. But basically, you can connect to that data and explore that data. Once you have explored it, you can then create a logical data warehouse, which we again will understand slightly later on what it means. We will then also see into Apache Spark clusters, which is a part of a different offering within Azure Synapse Analytics platform. And that part of offering will enable you exploring your big data volumes using the PySpark syntax, for instance. Now, you might be wondering, why would I use PySpark in Apache Spark cluster or versus serverless SQL pools? The difference there is mostly also what are your data engineering and data analyst teams using on a regular basis as a syntax to explore your data. If you have mostly experts that are coming from SQL background, they might be more comfortable in exploring your big data workloads using the CSV, Parquet files, etc., using SQL syntax. In that case, you can use serverless SQL pool. With Apache Spark, those are mostly teams that are coming from big data world, and you might be using then PySpark, Scala, or you can even use R or .NET within the Azure Synapse Analytics notebook environment. In other words, if we wanted to summarize Azure Synapse Analytics, it's just a unified platform that provides different clusters and different types of computes that will enable you work with different types of data. And it both has storage options and compute options. Another aspect that we see on the slide is the multitude of different languages. For example, you can see here SQL, you can see Python, .NET, etc. And of course, this language's choice will depend also on the cluster type that you're using. For example, if we are using dedicated SQL pools, we're going to be using the T-SQL syntax to create our tables, to distribute our tables across the distributions of our massively parallel processing engine. We will be using the T-SQL syntax also to explore our data and transform it. So basically, these syntaxes are dependent also on the cluster that you use. On the left-hand side of this slide, we have the different options that are there and that are available thanks to the fact that we are on the Azure platform and we are unified with all those features. For example, the security option, which will include RBAC configuration, the role-based access controls, which will include also access control lists if you are working with data lake storage accounts, and all those features that are on the Azure platform available, they are also unified with Azure Synapse Analytics, which means that we can leverage them and work comfortably with all those features without having to do some external integrations. So we have also the Azure Data Lake storage that is mentioned on the slide, which is going to be our underlying storage account. Because let's imagine that you are working with CSV and Parquet and JSON files, and you are using Spark cluster from Azure Synapse Analytics, and you are trying to explore the data as a starter, and then you are going to be transforming it using PySpark, and finally saving it into some storage. And that storage can be your Azure Data Lake storage account that is attached by default to every Azure Synapse Analytics workspace. And this also implies that during the creation of Azure Synapse Analytics workspace, you'll need to also create, during the provisioning, you'll need to either create an Azure Data Lake storage account that you will attach to your Azure Synapse Analytics workspace, or you'll need to select an existing one that will be considered attached and considered as the default Data Lake storage account for your workspace. So basically, Azure Synapse Analytics is a unification of different compute and storage options for creating modern data analytics solutions on top of that. Now let's have a brief overview of the Synapse Studio, which is the web interface, the graphical user interface where we can work with Azure Synapse Analytics. So what do we see here? On the left-hand side, we have what we call the hubs. You can see the Home Hub, the Data Hub, the Develop Hub, Integrate, and so on. In the middle section of the screenshot, you can see the Synapse Workspace, which is basically the shortcuts to some of the options with Azure Synapse Analytics. For example, Visualize option provides us integration with Power BI. Ingest option provides us integration with Azure Data Factory. Pipelines, well, actually, that is the same feature that is simply present also in Azure Synapse Analytics. So if you are familiar with Azure Data Factory pipelines, you can actually use that feature in Azure Synapse Analytics in the same way, which means that it gives you an extra possibility or extra tool to work with your data transformations and ingestion from within Azure Synapse Studio. Let's go to the next slide. And here we see a little bit of overview of different hubs. So from the Home Hub, you can just get quick access to different options. So those are like shortcuts, right? And that's the screenshot that we saw earlier. The Data Hub is going to give you access to different features such as dedicated SQL pools. You can visualize your databases that you have created within your dedicated SQL pool. You can visualize the tables. If you create some logical data warehouse, which we'll be doing later on in the second portion of this video, you will see that that logical data warehouse, that database that you create in the serverless SQL pool, it's going to be also appearing under the Data Hub. We will have the Develop Hub, where we are able to save and visualize and run our scripts. So basically, in this Develop Hub, you'll get access to all of the different scripting options within Azure Synapse Studio, such as Spark notebooks. You can visualize the SQL scripts that you create for dedicated or SQL serverless pools, etc. The Integrate Hub, that one provides you that unified experience with the pipelines, where you can ingest data and do the full ETL/ELT transformation cycle from Azure Synapse Studio interface. So that basically means that if you are going to work with Azure Synapse Analytics different compute or storage options, you can actually use, instead of using Azure Data Factory, you could go for Azure Synapse Analytics pipelines to also do the ETL transformations of your data. And finally, the Monitor and Manage hubs, which will let us in the Monitor Hub, we will be able to monitor our status of the clusters, SQL serverless pools, dedicated pools, Spark clusters. We can monitor also the status and the behavior of our pipelines if we have some pipelines running. So basically it's just a monitoring hub which will give us some more logging and information about what's going on in the system. And the Manage Hub will let us see and manage all the different clusters that we create or that we want to modify the provisioning for example. That is to say, we'll see the dedicated SQL pools, the serverless ones, the Apache Spark clusters, and some other management options. So you might be wondering, okay, when should I use Azure Synapse Analytics? Well, the answer is simple. If you need to create enterprise scale data analytics solution and you need to have some kind of storage and relational data store, or maybe some data store that is working with semi-structured data, you will need to have Azure Synapse Analytics in the background. And in this training, for example, we're going to be using Power BI later on. So when you ingest the data, when you create data sets in Power BI, you will be connecting to Azure Synapse Analytics. And why is that? Well, because it's the best solution for enterprise scale data. For example, if we're working with structured data, such as we're trying to migrate some structured CRM data, Azure SQL data, or some SQL Server data into the cloud, you might actually work with Azure Synapse Analytics in order to build that relational data warehousing solution in the cloud before using that inside your Power BI data sets. Let's now see lesson 2, where we will speak about the serverless SQL pool portion of Azure Synapse Analytics. With the serverless SQL pools, we're able to visualize, monitor, and also explore our data sets that we have in the cloud. For example, we might have a data lake storage account where we have CSV files, Parquet files, and we might want to first explore that data sets. And then we might want to transform them and store them in the format of CSV, Parquet, or JSON files again. And in those cases, we might be more focusing on SQL syntax because maybe we have teams that are more familiar with T-SQL. And with Azure Synapse Analytics serverless SQL pools, you will be able to do that without really having to switch to some other type of platforms and computations. So you can do directly using T-SQL syntax. So benefits of T-SQL pools is simply that it's pay per use. So it's not going to spend any money in your subscription if you're not using it, which means that you can simply start using it straight away. And whenever you start using them, it is going to start spending money from your subscription. So let's imagine I'm going to explore some CSV files, and that contains some X amounts of gigabytes of data. Whenever I'm writing a SQL query using the serverless SQL pool to ingest that data, to visualize it, to explore it, to transform it, then it's spending some money from my subscription. When will we use serverless SQL pools? Well, the answer to that question is quite obvious, and we also can see a couple of use cases on the slide. So we will be using that for data exploration, for data transformation, and when we want to build the logical data warehouse. Now, the logical data warehouse, it simply means that we are not going to materialize that data sets that we have transformed. We're not going to materialize them as a physical data warehouse directly in Azure Synapse Analytics. It means that those tables will exist as CSV, Parquet, or JSON files inside our data lake storage account, where we will materialize them, which means that the billing will also happen on ADLS side of things for that storage. But the serverless SQL pool will be referring to that data sets as if they were SQL tables using some metadata that will be stored in the serverless SQL pool. And in the same way, the serverless SQL pool itself as well, it's a scalable on-demand compute. And that's why it's not spending any money even if you have a serverless SQL pool in your Azure Synapse Analytics by default. Whenever you create and provision an Azure Synapse Analytics workspace, you will always have a serverless SQL pool available there. Now let's have a look at the types of file that we can query, transform, and then materialize in using the serverless SQL pool in Azure Synapse Analytics. And with this serverless SQL pool, as you can see from the slide, you might guess that we can work with these three types of data. We can work with CSV or delimited text files, we can work with JSON files, and we can work with Parquet files. Now, as to the difference between them, to make a little recap, with the delimited text files, you might be familiar with them. Most of the systems that exist out there, they have the possibility to output the data in TSV, CSV formats, and those files are really easy way to write data. But they are not good for analytical queries. And why is that? Well, because they are not optimized in terms of the storage. When they are being saved to the storage, there is no way to read them fast enough because it's not a columnar storage, it's a row store, and there is no metadata on top of it, like that's the case, for example, for Parquet files. JSON files, if we wanted to give a definition or the easy description for JSON files, those are JavaScript object notation format files, which are basically easy for a human eye to understand because they have that hierarchical nested structure to, for example, describe products, customers, and quite often the JSON format is going to be used in e-commerce applications, in NoSQL databases, because it's easy to write and it's also easy to understand for human eye what are the descriptions in those files. And finally, we'll have the Parquet files. Now, Parquet files, those are optimized columnar storage, which are very useful for analytical queries, basically for reading. So they are the fastest and the most optimal ones to read. And in addition to that, they are compressed. You can have also some extra metadata on top of that about the different columns. So it's really optimized for analytical queries. The next topic and the next aspect of serverless SQL pools, once we have explored our data sets, once we have transformed them, at some point we will want to materialize that transformed data because we will need to, let's say, refer to that data sets as if it were SQL tables. And in order to do that, we'll need to materialize it as a logical data warehouse. Now, that logical data warehouse portion of things, it simply means that within our data lake storage account, we're going to be materializing, we're going to be saving those files in CSV, JSON, or Parquet format. And we're going to have that metadata on top of it that will let us refer to them as if it were SQL tables. Which means that if you are communicating with your serverless SQL pool's logical data warehouse using some API, you will refer to that data as if it were an actual table. Now, here on this slide, what we see is just the set of sequence of steps that we'll need to execute in order to create our serverless SQL pool's logical data warehouse in the cloud. And as you can notice, we would proceed in the very first step as if we were working with a usual SQL server or SQL databases. We will create a database. Then we'll need to create an external data source, which will be saying where our files will be stored. Then we'll need to define the external file format, which will define in which format we're going to be saving those files. And then finally, we will be able to leverage the previously created artifacts, external data source, external file format, in order to create our external tables. And that's why we're calling it the external table, because it's not really materialized inside the Synapse Analytics. And there will be a lab exercise on that you will be doing later on. Let's now have a look into Apache Spark offering, or the Apache Spark cluster in Azure Synapse Analytics. And before going into understanding how we work with data when we work with the Apache Spark notebooks in Azure Synapse Analytics, let's first understand what is Spark, or make a little refresher if you already know what is Spark. Now, in Azure Synapse Analytics, Spark is presented as a Spark as a service offering, which means that you do not have to create the Spark cluster yourself, and you do not have to maintain the Spark cluster yourself. You will just provision the Spark cluster. You'll just specify how many nodes you need to have, how much memory you would like to have per node, and in the background you'll have that managed Spark cluster instance created for you. On the right-hand side of this slide, we have the diagram that represents the main components of a Spark cluster. And if you're not familiar with it, basically Spark itself, its cluster, it's a framework that exists outside of Azure, and you can also have it in the open source format outside Azure. And that offering, that framework, is basically a framework that is doing in-memory parallel processing, in-memory computations on the data sets that are called resilient distributed data sets. So that essentially means that your data is going to be distributed across a cluster, which will be able to make quick computations on your data sets that are spread across these executors that you see. And as you can see, the executors themselves, those are simply processes within our worker nodes, this light blue nodes that you see on the slide. They are called worker nodes, and they are doing the job, basically. They are splitting, your work is split across the cluster, and your cluster operates on that resilient distributed data set. Cluster Manager is the component within this framework that is acquiring executors for your work. So it's computing how much executors will be needed for some specific tasks, and it's assigning them for your work. We have also the driver program, which is the main node within our cluster, and that one is more responsible for administrative type of work. The storage portion that you see on the slide, the file system, the data lake store, that portion is basically our underlying storage from where we're going to get our data sets, the CSV, Parquet, JSON files that we're going to transform, use the full maybe ETL transformation lifecycle and on them. And then finally, we're going to be materializing back those data sets into our data lake storage account. And why do we need to have that layer? Well, that's because in Spark, you do not have any storage by default. You need to attach or mount a storage. And in this case, we're going to be using in our Azure Synapse Analytics, we can use directly the Azure Data Lake storage account that is attached by default to your Azure Synapse Analytics workspace, the one that we saw exist, we need to create when provisioning Azure Synapse Analytics workspace. So in Azure Synapse Analytics, Apache Spark cluster is basically Spark as a service. You do not need to install that yourself. Now, how do we use our Spark notebooks in Azure Synapse Analytics? And as you can see from this slide here, on the right-hand side, we have a little demonstration from Azure Synapse Analytics Studio, and you will see that we are currently in the Develop Hub here. And on the left-hand side, we have the notebooks. We have only one notebook in here. And this specific notebook is doing some computations on our data. And as you can see, the name of the notebook already gives us an idea what we're doing here. We're just exploring our sales data. And that sales data could be CSV, Parquet, or JSON files. And basically, we're going to be using the PySpark syntax, or we can use also Scala, R, or even .NET in order to explore that data. And typically, in order to explore the data, we would need to connect to that underlying storage where those files are stored, start writing scripts to explore it, visualize the columns, maybe qualify or quantify the data that we have. And once it's done, we can transform it a little bit and then materialize again inside our data lake storage account. So we will be doing also, we will be having a lab where we will be working with Apache Spark notebooks. As you can see on this slide here, we try to specify here the main phases of what you would do when working with data in Spark. Of course, this is not the exhaustive list, but those are the main tasks that you would usually do when working with Spark notebooks. And as you can see here, we say data frames. Data frames, those are the data sets with which we're working in Apache Spark. So that's the higher level abstraction, that's an API that lets us work with higher level data. So we don't need to speak to or work with the data that is situated on the lower level, closer to the physical layer, which means that that's our resilient distributed data set. So we no longer need to work with that. And we can also use some SQL expressions in Spark in order to run queries and more analytical queries on our data frames. In Spark notebooks, we're also able to visualize our data sets, and as you can see here, we can, for example, visualize as a histogram some of the data on which we made a query here. We made a little SQL cell in here where we were visualizing later on the results. If you are working more with data science type of activities, you can also visualize the distribution, some statistical properties of your data set. So it's really quick way to visualize quickly your data set distribution or what type of data you have there inside directly the notebook environment. Now that we have seen the Apache Spark clusters in Azure Synapse Analytics and we have seen also the serverless SQL pools, let's have a look at the dedicated SQL portion of Azure Synapse Analytics. And this is lesson 4, analyzing data in a relational data warehouse. So in this part of the lesson, we will understand why we might want to create our relational data warehouse in the cloud and how to work with that data warehouse in the cloud. So in general, once you have ingested your different data sources into Azure Synapse Analytics, you will create your relational data system in here. As you can see on the slide, on the right hand of the slide, you see that we have some fact sales table that is related to dimensional tables. So we have a dimensional table called dim customer for customer information. We have dimensional table that is containing information about store information, dimension employee, etc. Now, when we design our modern data warehouse in the cloud using the dedicated SQL pool, we need to create this type of design, this type of star schema, similarly to what we would do also in Power BI when working with enterprise scale analytics. Now, why do we need to create the star schema? Well, that is needed because we will need to remove as much redundant information as possible into dimension tables. Because with the massively parallel processing engine in Azure Synapse Analytics, we're aiming to distribute our tables across the 60 distributions of massively parallel processing engine of Azure Synapse Analytics. And we need to make sure that all the data that would have been duplicated if we were storing it in our fact sales table needs to be pushed into that dimensional tables. So for example, the customer information, we don't need to have that in each of the rows for our fact sales table if we can simply have some link with the fact table. In fact table, we will be storing mostly transactional information. For example, in this example, we're having sales information that will be stored in our fact sales table. Transactions about purchases on products, transactions about maybe delivering them, etc. And this star schema is going to enable us for a flexible and scalable design for later on using that schema inside those data sets inside Power BI for analytical enterprise scale reporting. When we're working with Azure Synapse Analytics and creating data warehouse tables, the typical sequence of steps that we would need to execute would be this one that you see on the slide. And as you can see, we're first starting with creating a dedicated SQL pool. Why is that? Because, well, the dedicated SQL pool does not exist by default in Azure Synapse Analytics Workspace like that was the case with the serverless SQL pool. Because you might or you might not need a dedicated SQL pool and the data warehouse portion of Synapse Analytics. Now, when you need that, you need to first provision a dedicated SQL pool according to your needs, and that dedicated SQL pool instance, whenever it is launched, it's going to consume money from your subscription. That dedicated SQL pool will then enable us creating all those dimension tables, fact tables, and staging tables, etc. inside our dedicated SQL pool, which will be materialized in Azure Synapse Analytics. So even though the storage and the compute are separated from each other in our massively parallel processing engine of the dedicated SQL pool, the data warehouse, the modern data warehouse that we're creating, is going to be materialized inside Azure Synapse Analytics. So we can create internal tables. And once we have that, we will then be able to run analytical queries on top of it. When we are working with our data warehouse, most frequently, the staging tables that you will be creating, they are going to be used for loading data into those tables. And once you have loaded the data, those are like intermediate tables. From the staging tables, we will need to put the data first into the dimension tables, and then we will load the stage data into the fact tables. And of course, you will need to also do some post-load optimization. Now, in general, there's a lot more to this topic. For example, when you're working with a dimensional table design in Azure Synapse Analytics dedicated SQL pool, you need to make sure that depending on the table you are storing it, the distribution of the table is designed properly. The index design is also very important. And we have a couple of good articles on our docs.microsoft.com website where you can actually see what type of tables will need what type of distribution and how to optimize your indexing schemes and everything else for your dedicated SQL pool. Another aspect of acquiring the data inside our data warehouse, well, typically what you will be doing is summarized on the slide. So we will be aggregating measures by dimension attributes. Usually dimension tables, they are used to support our analytical queries. We can use some ranking functions. So when you would like to, for example, display the amount of sales for some specific year, you might also want to rank those results into different groups depending on which quarter was performing better or which region was performing better. So those ranking functions can be useful to classify and group your results for the analytical queries. And also you might want to quite frequently know how many rows you have inside your table or inside a specific group of results. And when we're working with enterprise scale data, you might want to use some approximation functions instead of waiting for the full count of the full rows. And those functions use some math behind the scenes to make a really good approximation, but to do it much faster. So you will not have, let's say, the exact amount of count of your lines in the table, but you will have quite a good approximation that is also fast to run. And those functions are really important when we are working with very big scale of data and big volume of data, because when we have billions of rows, we can no longer accept waiting 10-15 minutes just to have the count of the lines. And in the lab, you will be seeing all those different functions in more details. You will explore a little bit how you can work with dimensional design in Azure Synapse Analytics dedicated SQL pools, and much more. So with this, we have seen an introduction to Azure Synapse Analytics dedicated SQL pools, serverless SQL pools, and Spark clusters. We will have also a little bit of demo on this part, and of course, don't forget about the knowledge check questions. Thank you. Demo for Module 3, Synapse Analytics Workspace. As we can see, we are currently connected to my Synapse Analytics Workspace, where we have the different hubs on the left-hand side, the Data Hub, Home Hub, Develop Hub, and we can navigate throughout these hubs by clicking on them. In my Data Hub, I have the different artifacts that are associated to the Synapse Analytics Workspace, my lake databases, my SQL databases. Those could be the logical data warehouse portion or the physical data warehouse in the cloud associated to my dedicated SQL pool. On the linked portion, we have the data lake that is associated to my Synapse Analytics Workspace. And we can see that there is one present here. And when we click on the container that is called files, we can see the different folders with CSV, JSON, and Parquet files that we have stored in that data lake. In the Develop Hub, we have the different scripts that we saved. For example, we have the SQL scripts, Apache Spark notebooks, and we have also associated some Power BI datasets to the Synapse Analytics Workspace, and we can also visualize some of our reports directly from Synapse Analytics. On the left-hand side, among the other hubs that we have in here, we can see our Integrate Hub, which will let us create pipelines, which are code-free data transformations usually used by data engineering teams to ingest data from various sources, transform them, and bring them into Azure Synapse Analytics or into data lake storage accounts or into some other data destinations. We have here the Monitor Hub, where we can monitor our status of SQL pools, SQL requests. So if I want to investigate one of the SQL queries that I have ran previously on my dedicated SQL pool or on my built-in serverless SQL pool, we can visualize that in here. And finally, in the Manage hub, we can manage the different aspects of our clusters, such as create or recreate new clusters for dedicated SQL pools. We can create Apache Spark clusters, Apache Spark pools from this hub, and this will let us also do the scaling of our clusters if needed, and some other configurations, as you can see on this left-hand side. Let's go into our Data Hub, into the Workspace portion, and refresh the list of SQL databases. As you will notice, currently I only have a dedicated SQL pool that is called SQL Pool 01, and that one has some tables. We can also create some external tables in it, and currently it's empty. Let's see if we have any external data sources and file formats. So as you can see, it's quite empty, and you can also refresh to see if there is anything inside. Now, what we're going to do first, we're going to explore our data sets that we have in CSV Parquet format in our data lake storage account that is linked to our Synapse Analytics workspace. So these ones here, the CSV files, and for example, and we will be exploring them using our serverless SQL pool, which, as you remember, is a non-demand cluster which is scaled automatically for you to explore your data that you have in the cloud. So for this, I'm going to move into the Develop Hub, and I'm going to use this first script, which, as you can see, I organized in 2 folders, and I have saved them as files. I have published them using this Publish All button in my workspace. We will be leveraging this OpenRowSet function in order to use this bulk load of our CSV files into our workspace, and we're defining the schema, where we're specifying what are the column types. And as you can notice here, we're connecting to our built-in serverless SQL pool, and we are going to run this query. And as you can see, my data is displayed as a collection of rows and columns, as if it were an actual SQL table. In reality, those are CSV files. And using most of the T-SQL commands, you can explore the data that you have in your data lake store, which is usually big data workloads, Parquet, CSV, and JSON files. And here we have a couple of scripts that are going to do the same thing, similar thing with JSON and Parquet files as well. So we're going to run that script, and as you can see, we're retrieving the information, and of course in the JSON file the documents are nested with that hierarchical structure. Now let's see how we can create our logical data warehouse with this script here. And as you can see, we will need to first create our database. So let's execute this script, and don't forget that we need to execute that on our built-in serverless SQL pool, because we're creating the logical data warehouse. We're going to run this script, this portion only, and we're going to, in the same time, monitor if our SQL database, our logical data warehouse, is created under this SQL database portion. So I'm going to refresh this. As you can see, my query is still being executed, and it's still retrieving the result. Okay, so we have now our serverless SQL pool database created, and if we refresh the list, we will see that our serverless SQL pool has now a database called sales. We will now specify that we want to use this database, and we will need to specify external data source with this portion of code. And then we will be specifying our external file format. As you can see, we are going to be materializing our logical data warehouse in the format of delimited text files. So those are the CSV file formats that we are going to define in here from lines 15 to 24. And before that, we need to specify where we are going to be creating those files, materializing that logical data warehouse. And this is going to be our connection to the data lake store that we have created prior to that. So if I run this little portion of code here, and we refresh at the same time the external data resources portion of my serverless SQL pool database, I'm going to just refresh this, and we're going to see now the sales data external data source that I just created. In a similar way, we're going to create this external file format, and as you can see currently, if I refresh, it's empty. So we will create one here, and then we can create our external table. So let's refresh this list, and you will see that we have our CSV format. For now, I do not have any external tables. So if I refresh that list, you will see that there's nothing. And as you can see, within this lines 26 up to line 44, we are going to be creating our external tables using the external data source and external file format that we created, that we defined earlier in the previous script. So I will run this portion and we will wait till our table is created and we will refresh that. So as you can see here, I have a set of metadata objects which are referring to my CSV files that are stored in the data lake storage account, but we can run SQL queries on them. For example, this select top 100 rows in order to visualize that as if it were an actual SQL relational table, although it's not a physical data warehouse in the cloud. I will close these scripts, and now we will have a brief overview of how you could run queries using the Apache Spark cluster. And for that, we will go to my Develop Hub, and we will expand the portion of my Spark notebooks, which have been also prior to that saved into my workspace. And we will click onto this notebook where we have prepared our code. And for Spark cluster, we will be needing to attach our notebook to the Spark cluster, and we will need to run and execute the cells, which I will not do for the sake of not rerunning the same stuff again. You see that my cluster is not yet started, the session to the cluster, but you can see the outputs of those cells. And this is something that you will be also doing in the lab in case if you follow the lab exercises. And you can see that we're using the familiar PySpark syntax in here, and in order to explore our data, to understand what's the structure of the data, and then we're going to be simply running some SQL queries on that in order to, again, explore that a bit more. In Module 3, we got introduced to Azure Synapse Analytics with the serverless SQL pools and logical data warehouse, with Apache Spark clusters, with Apache Spark notebooks, and we also got introduced to the dedicated SQL pool portion of Azure Synapse Analytics. Knowledge check for Module 3. Are you ready? Question 1. Which feature of Azure Synapse Analytics enables you to transfer data from one store to another and apply transformations to the data at scheduled intervals? Serverless SQL pool, Apache Spark pool, or pipelines? That's right, the correct answer is pipelines. We can ingest data using pipelines and schedule them and trigger them on scheduled intervals. Question 2. You want to create a data warehouse in Azure Synapse Analytics in which the data is stored and queried in a relational data store. What kind of pool should you create? Serverless SQL pool, dedicated SQL pool, or Apache Spark pool? That's right, we need to create a dedicated SQL pool. Question 3. A data analyst wants to analyze data by using Python code combined with text descriptions of the insights gained from the analytics. What should they use to perform the analysis? Apache Spark Notebook, pipelines, or SQL script? That's right, we need to create Apache Spark Notebook. And finally, question 4. In which of the following table types should an insurance company store details of customer attributes by which claims will be aggregated? Staging table, dimension table, or fact table? And the correct answer is dimension table. Don't forget that the dimensional tables are the ones that support our attributes and our analysis. That was our last question for the knowledge check for Module 3. I hope you enjoyed it, and see you in the next module. Hello everyone, and welcome to Microsoft's Designing and Implementing Enterprise Scale Analytics Solutions using Microsoft Azure and Microsoft Power BI. My name is Anna. This is Module 4, Prepare Data for Tabular Models in Power BI. And in this module, we will be understanding why we need to use the star schema design. We will understand how the DAX queries work in the background. We will have a little refresher on that part. And then we will understand why in an enterprise scale, it's a key to optimization to properly design our tabular model in Power BI. So let's have a look at our agenda for this module. So first we will look into choosing a Power BI model framework, where we will understand the basis of the star schema design and why it is important to use that design. Then we will speak about scalability in Power BI, especially on an enterprise level. And then finally we will understand how you can create and manage scalable Power BI data flows and how they can help you in optimizing your workflows. So let's first speak about choosing a Power BI model framework. And this is our lesson 1. When we're working with enterprise scale data sets, it is no longer sufficient just to connect to our data source and start the reports. We need to properly choose the design of our tabular model in Power BI. And as you might remember, in Power BI, when we are running an analytical query, let's say when we are refreshing a report, when we are refreshing a visual within a report, what happens in the background, the DAX, the data analysis expression, is going to be executed in the following order. First, we are going to execute the filter, then group, and then it's going to be summarized. And in Power BI, the tabular model, essentially it's just the data set that is represented the way your data is represented in Power BI. And the most recommended design is the star schema. So let's have a little refresher on our star schema. So with the star schema, we will be designing our data that represents, in this example, sales data, which is transactional data, as a fact table. And usually those tables, especially on an enterprise scale, will contain billions of rows. All the data that can be moved out into dimensional tables, such as information about products, information about customers, information about sales territory, that will be duplicated if we put it in the sales factory seller sales table, we should push it into dimension tables. And we will have some links between those tables that will let us later on use that information in the filters. So let's say when you run a data analysis expression, a DAX expression is run, the dimensional tables, they are going to support our analysis, which means that the filter and the group portions of our DAX query are going to be executed first using the dimension tables. And then the information that is in the fact tables is going to be summarized. So here, whenever we're running a DAX query, this table design is going to be optimal for our enterprise scale analytics. So for example, when we ask ourselves how much sales did we do in 2022 for different quarters and for this specific product category, the analytical expression will first filter from the dimension tables. It will find the information about the products that we're filtering for, and then it's going to do the grouping per quarters, which will then summarize the factory seller sales data, meaning the amount of sales that we did for that specific product. And that's how we will compute the sum of quarterly sales for 2022. Another important aspect when working with our tabular model is how Power BI is going to connect to the data source. And as you might already know, in Power BI we will have different connectivity modes, such as live connection or exploration mode, which is more for SQL service analysis services. We will have the import mode, which is the one that is most commonly used, and we will discuss that in a couple of moments. And we will have the direct query, which will be mostly used for directly connecting to some data sources and retrieving data at the query time. And in this portion, we will be trying to understand what is the best depending on your data type and, of course, in an enterprise scale and for our data analytics. So first here, as you can see, we will be looking into the import model. And the advantages of the import model is that we can connect to a variety of data sources. So it's the most flexible one to connect to different data sources. For example, here you can see we can import data from Azure SQL, we can import data from spreadsheets, from social media, etc. And of course, we will be designing the relationships in the star schema design as we saw previously. Another important advantage of the import mode is that we're going to be supporting all of the DAX and Power Query functionality, and as you might already know, Power Query is going to be used to transform our data. We will also be supporting calculated tables, so there are really lots of advantages for the import model, and in general, we will be always recommending to go for an import model design. However, among the limitations that usually push people choosing another different model for data connectivity mode is actually the two ones that we see on the slide. So we are limited for the imported data set size. The limitation is 1 GB. What does that mean? Well, that means that once the data is imported into Power BI and compressed, the max is 1 GB. So it's not the original data source size limitation, but the one that is imported into Power BI and compressed. Well, of course, you will be thinking, yes, but in Power BI premium capacity, we're no longer limited to 1 GB if we use the large dataset format. And that is true. However, we're still having a limitation. So that could be a big limitation for different design choices that you might be having out there. And finally, for data refresh as well, we're limited. So we have 8 times per day limitation for shared capacity, and if we're using premium capacity, we're limited for 48 times per day in the dedicated capacity. So still there is this limitation. So let's look into another connectivity mode, which is the direct query model. And as you might remember, and as we will demonstrate on this little animation on the slide, you'll see that in the direct query, when we're going to refresh our visualization on a report or on a dashboard in Power BI, actually the data source will be queried in real time, which means that we're no longer limited in terms of the amount of refreshes per day, and also all those limitations of import model are not applied anymore. However, with the direct query model, also there are some limitations. And the major one is that not all the data sources will support the direct query mode. Typically, most of the sources that support direct query mode, those are SQL databases, Azure SQL, Azure Synapse Analytics, and you can also check the full exhaustive list on our docs.microsoft.com website. So in terms of other limitations that we might have with the direct query is that we do not longer support all the Power Query transformations. And in general, when working with direct query, and in most of the models, we will always recommend doing the transformation as close to the source as possible. Another limitation that happens quite a lot with the direct query is that the analytic query performance can be slow, especially that if your original data source to which you are connected is not optimized well enough. For example, there are some indexing problems. And another possibility for that is also the direct query maybe is not properly set up. Among the benefits, as you can see on this left-hand side of the slide, is that if you are using row-level security, that will be directly applied using the direct queries, which means that your data source row-level security configuration will be already applied using the direct query. You no longer need to set that up inside Power BI. It also works well with the data sovereignty restrictions, which means that if you do not have the right because of some GDPR or local data restrictions in that specific region, you no longer need to import the data and store it inside the Power BI because you're connecting to the data source directly. Another data import model is the composite model, which means that we're going to be using both a combination between import mode and direct query mode. So as you can see on this first portion of the slide, we're importing from different data sources, and we also have a portion that is using the direct query, so querying the Azure SQL in this specific example. And the biggest advantage of a composite model is that with this composite model, we can boost the direct query performance because we are going to be querying cached data. And that's the typical use case when we will go for a composite model. So let's have a look at some of the benefits and limitations. And as you can see, even though we are boosting the performance of the direct query, we still will need to refresh the import portion of it, which means that we still have some limitations and that could be slowing down our performance. Now, if we wanted to summarize the general guidance for model framework choices for enterprise scale data analytics, in general, whenever it's possible, choose import mode. Why? Because we're quite flexible there. Most of the Power Query transformations are supported, and it's going to support most of the data sources. Direct query is going to be a best choice when you cannot work with some of the specific data sources because of their limitation on the size. It's a huge data set, so then direct query should be chosen. And composite model generic guideline would be to use when you need to boost the query performance of your direct query model. Now that we have seen generic guidelines about model framework choices, let's have a look at scalability in Power BI. And in this specific module and in this lesson, we will be speaking about scalability of models, and especially why it's important on an enterprise scale. Because as you might remember, we're speaking about big tables, huge data sets, and we need to make sure that our model design is going to be able to handle that scale, that's flexibility in terms of the data sets. So when the data set size becomes bigger, we need to make sure that the model will handle that charge, and our reports will be updating and refreshing quickly enough to provide the best user experience. So how do we design for scalability? Well, in order to design for scalability, we need to first of all choose the correct framework. We need to design star schema inside our Power BI dataset. And then we need to also try to do as much preparation work as possible in our data warehouse behind the scenes. So we need to have that Azure Synapse Analytics data warehouse that is also set up properly with star schema design if we're using dedicated SQL pool. And of course, we need to make sure that we have proper indexing strategy. Especially that's important when we're connecting using direct query, because we want our data source from where we're querying the data directly in Power BI. We need to make sure that it's fast enough, responding fast enough to provide quick refreshes for our visualizations. And also, it's recommended to do the transformations as close to the source as possible. So all that Power Query transformations that you're going to do, not only you need to check for query folding, but also you need to make sure that if you can do that closer to the source in Azure Synapse Analytics, then please do that in Azure Synapse Analytics, and you can also work that out together with your data engineering teams. Another recommendation when we work with enterprise scale analytics, that would be, of course, enabling large dataset storage format. And with the large dataset storage format, you can also enable that for all premium licenses, so all your premium users will be using large dataset format. You can also enable that for all the large dataset format. You can enable that for all the datasets that are created in your workspace. And this is a little demonstration on the slide how you can do that from your portal and by going into the premium settings and then enabling that from that drop-down menu. Now let's move into another portion of this module, Lesson 3, where we will be speaking about creating and managing scalable Power BI data flows. And before understanding how data flows can improve performance or help you in applying your ETL transformation logic, let's first understand what are data flows. And Power BI data flows by themselves is just a reusable data tables that you can define in your workspace using the Power Query online, and it will enable you replicating some of the logic that, especially in case if you don't have some data warehouse behind the scenes. Now, in terms of what Power BI data flows are, we have this little schema on the slide which demonstrates it quite well. So on the left-hand side of the slide, we have our SQL databases, we have our different data sources, which are then going to be ingested in an Azure Data Lake storage. So at the moment of refresher of our data flows, it's going to be loaded as files in our ADLS Gen 2, and then it's going to be loaded into our Power BI service. And basically, it's a very good choice when you do not have data warehouse behind the scenes, like Azure Synapse Analytics, for example, and you don't have any ETL transformation logic. but you know that you would like to have that logic and you would like to replicate it. You would not like to do that over and over again. You can actually create this Power BI data flows to boost up your performance. There are some features of the Power BI data flows that are available only for the premium capacity, and we're going to have a brief overview of that as well. But overall, that data flow functionality is available for all of the most of the licenses, and you can make use of it for boosting your performance. So here we have the summary of the benefits and limitations, and among the limitations you may see that we do not support row-level security, for example, or there are some limitations for if you are not using premium capacity, but overall it will reduce the number of the iterations that you will be doing for the ETL logic if you use data flows. So here are a couple of features that are available in Power BI Premium capacity for the data flows. And as you can see, you can define tables, because data flows, they are like tables. So you can define the data flows using computed entities, linked entities, and there are a couple of other features that are not supported with other SKUs. So let's have a look at a typical sequence of steps that we would be using in order to create those reusable data flows. For example, here we are bringing the example of creating a data flow using the option to define new tables, but we can also define new data flows using a linked table option or computed table or using import or export options, so you have the choice out there. We then can refresh our data flows, and when we are prompted to refresh our data flow, actually that schema that we saw earlier, where the data is being loaded into a DLS, that's what happens behind the scenes. And we can, of course, connect to our data flows after that from Power BI Desktop using the Power BI Data Flow connector that you are seeing on this right-hand side in the screenshot, where we're choosing among the options from the Get Data button, we're choosing the Power Platform, and then we're going to choose the Data Flows option right here. So basically, data flows is just another way to improve and boost up your performance, especially if you don't have any ETL logic behind the scenes. This is demo for Module 4, where we learned how we can build our star schema and why is it important to use the star schema. So what we're currently looking at, it's a Power BI desktop file that I opened in my Power BI desktop, and it's called Sales Analysis. So this is a report that we have created, which is based on our star schema design. So we can have a look at our star schema design if we navigate to this model portion of my screen, of my Power BI, and you can see that we have our sales table that is designed in our tabular model as a fact table, which means that all the transactional information is stored in the sales table. And we do have the dimensional tables, which are designed as dimensions for our for supporting our analysis. As you can see, we have the sales order, we have the reseller information, customer information, which do not need to be replicated in our sales table. And these are the descriptions of our different columns. And as you can see, we tried to have the most of the redundancy moved into dimensional tables, which support our design. Now, when we go to the report and when we test out the filtering, for example, bikes here, thanks to the dimensional design, we are still able to have that different informations based on the bike sales, based on the year sales, because we are able to have that information about which category products we sold the year before. And this is giving us all that possibilities to switch between different sections within our report. So in this module, we were targeting to understand how to properly choose the table design in Power BI tabular model, why we cannot connect directly to our data sets and ingest them before even designing the star schema model. We understood why we can use data flows in what use cases, which import modes are recommended for enterprise scale data sets. And I hope you enjoyed this lesson. We'll see you in the knowledge check. This is the knowledge check for Module 4. Are you ready? Question 1. Brianna is a data modeler at AdventureWorks who developed a manufacturing model, which is an import model. Brianna needs to ensure that manufacturing reports deliver real-time results. Which type of table should Brianna create? aggregation table, partition table, or hybrid table? That's right, she should choose a hybrid table. Question 2. Musaf is a business analyst at AdventureWorks who wants to create a new model by extending the sales dataset, which is delivered by IT. Musaf wants to add a new table of census population data sourced from a web page. Which model framework should Musaf use? Composite, direct query, or live connection? That's right, he should go for the composite model. Question 3. Ivor is working on an analytics solution that requires ETL logic to be applied to a table that sits outside of the data warehouse. Multiple analysts need to use this supplemental clean data in their reports, and it's important that all reports reflect the exact version of the cleansed data. Analysts don't have access to the data source. What should Ivor do to provide analysts with this data at the lowest access level necessary? Create a Power BI dataset in a shared workspace and give all analysts contributor access. Create a Power BI data flow in a shared workspace and give all analysts viewer access. Or he should create a Power BI data flow in a shared workspace and give all analysts admin access. That's right, the correct answer is that he needs to create a data flow in a shared workspace and give all analysts viewer access. Question 4. What is the most efficient approach for data transformation when designing data models for scalability? Data transformation should always be done using Power Query in Power BI. Data transformation should be done as close to the source as possible before reaching Power BI. Or data transformation should be done using DAX after data is ingested and loaded to the model. And that's right, we need to make the data transformation as close to the source as possible before we reach Power BI. That was our last question for Module 4 Knowledge Check questions. I hope you enjoyed it and see you in the next module. Hello everyone and welcome to Microsoft's Designing and Implementing Enterprise-Scale Analytics Solutions using Microsoft Azure and Microsoft Power BI. My name is Anna. This is Module 5, where we will learn how to design and build tabular models. Alongside with table model design, the model relationships form the basis of our tabular model. Relationships, they are responsible for the propagation of our filters to other model tables, and they silently provide the whole filter experience and the whole query experience so that it's optimal and running smoothly. And there is a lot to learn about relationships, the filter propagation paths, and it can be challenging, especially if we also consider the DAX, the data analysis expressions, and how they work along with the filters. And you can always use the reference for DAX expressions when you are working with that stuff. So in this module, we're going to be talking about the following lessons. In Lesson 1, we will speak about creating Power BI model relationships, how are the filters propagating. In Lesson 2, we will speak about DAX concepts. We will have a little refresher there, and we will also speak about several DAX functions that are modifying the filter context, and we will also recap those concepts. We will then speak in Lesson 3 about creating calculation groups and how you should optimize the performance using calculation groups. And finally, in Lesson 4, we will be speaking about enforcing Power BI model security, where we will speak about role-level security and object-level security. In Module 5's Lesson 5, we will speak about tools to optimize Power BI performance, and that will be about Performance Analyzer, Tabular Editor, and some other tools. As you can see, we have quite a lot to do, so let's get started with Lesson 1, where we will understand Power BI model relationships. So let's imagine we need to run an analytical query where we are questioning ourselves, what is the sales quantity for year 2022 or 2018 for product category A per quarter? So as you remember from the previous module, the relationship and the way that our DAX query will be executed in the end is going to first start with filtering, then grouping, and then finally summarizing. In addition to that, the model relationships within our star schema are going to silently provide us this filtering experience. So as you can see, first we will be filtering by the category of product category A in order to then understand what are the sales amounts for that specific year. And if we represent this with the star schema design that we learned in the previous module, you will see on the slide here that we have our sales table, which is our fact table, which has relationships with other dimension tables, and it has the filter propagation paths defined, which we can see with these little arrows. And yes, as you might notice from this schema, you will see that there is some relationships that are written 1 to a star, which means 1 to many. And then we have also the star icon, which always will mean that it's the many side of the relationship. We will look into the types of relationships in the next slide. So as you can see here, there are 3 types of relationships that we have. We have the one-to-many or the many-to-one relationships, which can have the cross-filter options on single side or on both sides. We have the one-to-one relationships, which can have both cross-filter options. And we have the many-to-many cardinality type for the relationships, and this is quite a rare one to use. Now, the many-to-many relationships, they are going to be used in cases where you have higher grain dimension tables. For example, instead of having a product information in your dimension table, you might be having product category. And that means that that product category, multiple lines in that table might be related to multiple lines in your, let's say, fact table, which will be your sales table. And in a many-to-many relationship, the sales table itself, the fact table itself, has to be also higher grain. In general, you should be always targeting to use the one-to-many relationship. Now, as you might guess, in one-to-many relationship, we are going to be relating one value from one table to multiple different lines in another table. For example, for the sales of a product, of a specific product, let's say some specific book, from our dimension table can be sold multiple times to multiple different customers. So we will have multiple different informations corresponding to that product sales in the sales table. In addition to that, when we are working with DAX expressions, with the data analysis expressions, you might use some of those functions to modify your filter context. For example, disable a relationship, or on the contrary, use some specific relationship. So with the related DAX function, we're going to be retrieving the value from the one side of a related table. In the related table function, it's quite similar to the related one. It's just it evaluates the table expression in a context modified by the given filters. The use relationship function is going to force the use of a specific relationship, as the name suggests. And it's useful when you have some inactive relationships between two tables and you want to use that inactive relationship, for example. The cross-filter function is going to modify the filter direction, or you can also use that to not use some specific relationship. And as you can see, there are quite some of them on this slide, and you can also use the docs.microsoft.com to find the full reference of DAX functions, that are using some specific relationships. Now, when we're speaking about relationships, we also need to understand how those relationships are evaluated by the query engine. So the regular and limited relationships is simply the qualification of the relationship depending on whether or not our query engine is capable of understanding what's the one side of the relationship. So regular relationship is the one where our query engine is capable of understanding straight away what's the one side of the relationship. Limited relationships, on the other hand, are the relationships where there is no guaranteed one side, and the query engine is not capable to understand that implicitly. Now, precedence rules, and performance preference, those are two different concepts. So for precedence rules, as you might understand from the naming, it basically means how are the relationships going to be evaluated, which ones are going to be evaluated as a priority. So in terms of the precedence rules, we will always prioritize the one-to-many and many-to-one relationships, and then we will be looking into the other ones. In terms of the performance preference, again, you should give priority to modeling your relationships using the one-to-many or the many-to-one. Now, once we have spoken about relationships and how they help our filters to propagate across the tables, let's understand some of the DAX concepts, and in particular, we will again make a little refresher on the way our analytic queries are evaluated, the order of the actions that are taken behind the scenes by the analytical engine to evaluate our DAX expressions. So let's say we're asking what are the quarterly sales for 2021. When we are refreshing a visual in our Power BI dashboard or report, this is what happens in the background. First, we are going to filter, then we are going to group, and then summarize. What does that mean when we look into our visual? Well, let's look into our visual here. So for the question for the analytical query, what are the 2021 quarterly sales? The filter portion of it will be, for example, our filter for CY 2021 on a visual. We will then group by quarters the results of our summary that is evaluated as a last part of this query. So as you can see, we have this histogram now, the bar chart, with quarter 1, quarter 2, 3, etc. Sales results. Now, as a little refresher, when we work with DAX, with data analytical expressions, we're going to be working with functions, with operators, and you can have a look at the detailed documentation when you are really working with them to understand which function is better suited for your specific evaluation. In general, as a best practice, it is always recommended to create variables in your DAX expressions. And that's something really basic, and you might have already known about it, but that's a very good practice to use, especially when you're working with enterprise scale data sets and you might have complex DAX expressions. Another aspect of DAX is, of course, the calculate function, which we could not leave out. And the calculate function is a very powerful one because it lets us evaluate an expression in specific filter context. Now, what does that mean? On this right-hand side of the slide, we see a table where we are evaluating the revenues for one specific red product. So we can basically use this calculate function to specify that we want to have the total of sales for Australia, Canada, etc. per specific red category of our product. And the powerfulness of this calculate function comes from the fact that we can use multiple different filters within the same expression, so we can pass them as arguments. And that's a function that we will recommend using a lot, especially on an enterprise scale, because you might have complex evaluations. And another aspect of DAX that we will touch on is the time intelligence functions. And this concept needs to be deployed under consideration that you have the date table enabled in your data model. What does that mean? Well, that means that you either need to ingest the date table from your data warehouse behind the scenes, which means that you should have one there, or there are multiple ways to create one, to generate one using DAX expressions again in Power BI, and there are lots of tutorials out there that you can use depending on your data sets, the types and what type of data you're working with. Now, once you have your date table, you can use DAX time intelligence functions in order to easily make some time computations. And this is really important in BI type of computations because you might need to, let's say, evaluate or return a single column that has computations for some sales dates for the year to date. And in that case, you can use, for example, the dates YTD year-to-date function that will enable you doing that computation. And that's why it's a very good recommended practice to have that date table so that you can use the DAX time intelligence functions. some other examples would be the total year to do function, another one the total quarter to do, the total month to do, dates between, and there are many more others that you might leverage in your DAX computations. Now that we have seen some DAX expressions and some modifications and optimizations that you can do with DAX in terms of your computations for enterprise scale analytics, let's now have a look at lesson 3, where we will understand what are the calculation groups and why we might want to use them. Now let's imagine that you created some implicit measures, or you need to create some measures for the sales, for the orders, and for some profits, and each of those measures are implicit ones that you create in your Power BI desktop. Then you're asked to create the same measures for the next year and year over year. So you might be thinking, yes, I can create those measures every time. But on the other hand, this will increase the complexity of your model, and it will be quite cumbersome to then understand what are all those different measures. And it will also increase the amount of the redundant work that you will need to do. And for that reason, to avoid that redundant work and to optimize how you are working with the measures inside Power BI, it is recommended to create calculation groups. And in order to do that, you will first start off by creating your implicit measures, as you would do typically. But for the rest of the measures that are similar ones, but just for year-over-year computations, you can use the tabular editor, which is an external tool, in order to create your calculation groups. And as you can see on the slide, we have our calculation items here for the year-over-year computation. It will make more of a neat model, and you will not redundantly redo the same work. So how do we create calculation groups? Well, for that we will need to use the tabular editor 2.x or later version. And from the tabular editor, which is an open source tool, and you can open it from your Power BI desktop in case if you are using the latest versions of Power BI, and you can basically then create them from the left-hand side when you right-click on one of your tables. So let's have a look at the slide that demonstrates that. So here we have an example of already created calculation group, and basically in this calculation group we're demonstrating the calculation group precedence. That's an important property for our calculation groups because it says Power BI in which order they have to be evaluated. If you have multiple calculation groups, you might want to specify which ones need to be taken as a priority and evaluated first, and then the next ones. Now this value of 10, if we had another calculation group that has a value that is lower, it means that this one with a higher number will be evaluated first. And within your calculation groups, there are other settings that you can set up, like ordering or dynamic format strings. Like the ordering will not affect your precedence. So on this slide, we have on this little screenshot on the right-hand side, we have the demonstration of the default ordering. So what do we have here? Well, here we have our calculation items within our calculation group. So we have current, PY, year over year, and year over year with percentage. On the left-hand side, we have the demonstration of the fact that by default, it's the ordinal order that will be used for your items within the calculation group. But this does not mean that your calculation group will be evaluated in a different priority. So it's not equal to your precedence. On the right-hand side, we have the demonstration of how you can change the order of the calculation group items, but this still will never impact your precedence. So precedence is a different property, and it's important to know that they are not the same ones. And if you want some calculation group to be evaluated first, you need to have a higher value for that calculation group in the precedence property. And finally, you can use dynamic format string property with your calculation groups in order to format differently the string. For example, here we have the example of sales for different countries. So you might want to have different formatting rules for those different countries. So as I mentioned earlier, we have now an example of how we can create a calculation group in a model. So here we have a tabular editor in the first part of the screenshot on the left-hand side, where we have all our tables. And here on the right-hand side, we have the demonstration of how you can use those calculation groups, how you can drag and drop them from Power BI desktop into your different visualizations and tables. So we had a look into calculation groups in previous lesson. Now let's speak a little bit about security. And this is lesson 4 for module 5, where we will be talking about best practices when you are working with object level security, role level security, and stuff like that. So first of all, when we are working with object level security, role level security, it's always good practice to start with star schema design, because the star schema design will also reinforce the security rules by first going into dimension tables and then propagating that to the fact tables. In terms of the security, we can have static rules and we can have dynamic rules. So let's imagine we have a fact table and we want to hide the whole table from our users. In that case, we can use a static rule. That's the simplest example of a static rule. With dynamic rules, we can actually perform a check before we're hiding portions of our table. Let's say we have sales table, and some of the rows are representing sales for one specific region, and some of the sales in that table represent another region. And we want the salesperson of the specific region to see only the data that is related to his specific region, his or her specific region. So, in that case, we can create dynamic rules which will be leveraging the username or user principal name function, which will first check who's the user that is running that report, that is viewing that data. And depending on that, only specific portions of the table will be shown to that user. Another best practice that we see on this table here is validating roles. So once you have configured your role level security, it's always a good practice to validate the roles by using the View As button in Power BI. Although it seems very obvious, but that's something that sometimes if we forget to validate, we might not have the configuration as we were planning it. So always validate that before publishing your reports. Another important best practice here is that we need to set up role mappings in advance before the users are accessing the Power BI content. And finally, the last one that we have on the slide here is more relevant to the direct query sources. When you are configuring role level security, when you are enabling that, actually using the direct query, you no longer need to reconfigure that, but you might need to configure the single sign-on. And whenever you're using the direct query, it's a best practice for the security purposes to configure the single sign-on if the source supports that. Another aspect of the security that we will be speaking about in this module is the object level security. And for the object level security, we have on the left-hand side of the slide the sequence of steps that we might execute that we need to execute in order to configure that. And on the right-hand side, we have the error message that the user will receive when object level security is applied. And by the way, as a refresher, object level security is going to hide either the columns of a table or the entire table from some specific users. Now, with object level security, again, we recommend creating roles. You need to create roles, and then you need to create the rules to apply those rules to the roles. However, a big consideration with object level security is that when your report consumers are going to see that error message where it says something went wrong, some of the fields are not displayable, employee salary in this example, that's a normal error message, and that means that our OLS is properly set up. However, the users might be actually experiencing some troubles to understand that error message. They might think that the report is broken, and this will end up in poor user experience. In that cases, it's better to avoid object level security and use some other options in order to overcome this type of limitations. So, for example, you could create a separate model for those users that are not supposed to see the subset of the tables or the subset of the columns of the tables. And finally, another consideration, if you are going for both RLS and OLS, in that case, please do not mix the same role for both. So you need to define separate roles for RLS and separate roles for OLS. In general, when we're working with data modeling and with security portion of things, it's recommended to use the user principal name instead of username function. Username function is going to check for the domain \username format of string, and user principal name is more flexible because it's also checking for the usernames that are in the format of a mail, corporate email, for example. It's always better to start by creating rules that are going to filter dimension tables. Try to use the fewer data sets, fewer roles. Don't multiply the roles within your security model. So this slide summarizes all those different security principles for the OLS and RLS. And the final aspect that we will speak about in this specific module is lesson 5, where we will be talking about optimizing Power BI performance. And in terms of optimizations, we can speak on different levels. So there can be the data source level optimizations, data model optimizations, visualizations, and of course the environment. So let's have a look at some of those aspects. When we are using aggregations, in general, they can improve the query performance over very large direct query data sets. And when you use aggregations, you are basically caching data aggregated in the memory level. And that's something that we will recommend using that. By the way, if you are using the automatic aggregations, which is a premium subscription feature, that will do that automatically for you, so you no longer need to set that up yourself. Another thing that we recommend for optimizing Power BI solutions is using the dual storage mode so that you boost the performance of your direct query models. And finally, for very large tables, it's more recommended to use hybrid tables where you will have multiple partitions. You will have a partition that will have that will be used for archived data, and as you can see, it will be our import mode partition. And then the direct query partition, which has to be small enough, which will be more for real-time data, which will be providing you quick query performance for your reports and dashboards. Among the different tools that we can use in order to optimize our Power BI models, we could group them into two different categories: retroactive tools and proactive ones. Among the retroactive ones is the Performance Analyzer and the DAX Studio. And if you're, for example, experiencing some slow report performance, your users are saying the reports are taking ages to perform, you will first start by investigating probably the retroactive tools. With the proactive ones, it's better to use them beforehand so that you can understand beforehand how you could improve your model. So Performance Analyzer, it's an internal tool that is available within Power BI Desktop, and it's recommended to use that, for example, to see if your reports are refreshing quickly enough. For example, if you are trying to understand how much time does it take to refresh some specific visual when you are modifying the slicer, when you are refreshing the visual or the report, and how you would typically use it. On the left-hand side, we have the demonstration of that Start Recording button, which is situated inside our Power BI for Desktop. And when you click on that button, you will start recording the performance, and you will be basically refreshing your report page. You'll need to refresh some visuals, maybe move some slicers. And once you stop the recording, you will be able to see, as you can see on this right-hand side of the slide, you will be able to see what are the different times that were taken in order to evaluate your DAX query, to evaluate parameters, and you will understand where is it taking the most of the time to refresh your reports, and you will be able to take it further from there. Another performance tool that will help us analyze the performance is the DAX Studio, which is an open source tool, which is mostly used for improving your DAX expressions to help you out in building your DAX expressions. But before going into the performance optimization part of DAX Studio and understanding how it can help us in improving the performance, let's have a look at how our Vertipack engine, which is the Power BI under the hood, working when we are running DAX expressions. So here we have our user that is submitting a query to our engine. And that could be, for example, a result of refresh of our report. So the query is going to be sent to our tabular model, as you can see at this step number 2. And the tabular model is then going to speak to the formula engine, which will then send depending on which of the connectivity mode you are using. If you are using import mode, it's going to be sent to the Vertipack engine. And if you are using direct query, then your query is going to be sent directly to the source of the data. So if we're working with a Vertipack import mode, so Vertipack engine, there are different mechanisms behind the scenes which are separating the storage from the analytical query, and it's also compressing the data. And that is then afterwards, your request is sent to the data source in any of the cases, be it Vertipack engine or the direct query. So with DAX Studio, what you can understand, what you can analyze, is basically you can see some metrics that are displaying how your Vertipack analyzer is performing. And you can see if there are some columns, some specific aspects of your data model that are slowing down the Vertipack analyzer itself. So for example, we have a demonstration here where we can see the column sizes within our model, within some tables. We can see how much percentage of the charge is being used on the database size, on the table size, etc. So that's a good retroactive tool. And finally, within that proactive tools, we have the best practice analyzer, which is a part of the tabular editor, which in its turn is an open source tool. And you can basically, within this best practice analyzer, understand if you are maybe missing out some things in your model. For example, if some of the evaluations might fail because you have missed out something in your measures, in your tables. So that's a good proactive tool, because you will be able to understand how to improve your model beforehand. And those are usually suggestions that you can use. It's not something that will be imposed unless if there is a big problem and you need to take it into account straight away. But most of the suggestions can be taken into account to improve your performance. So in this module, we were targeting to understand what are the different aspects of performance optimizations, of security, what are the best practices to implement the OLS, RLS in Power BI, what are the filter propagation paths, what are the different relationships that you can have between the tables, what is the precedence of those relationships, what are the calculation groups, and how to improve and optimize performance using calculation groups. And we also looked into the DAX expressions that modify the filter context and that can enable or disable the usage of one specific relationship. I hope you enjoyed this module. We will see each other in the knowledge check. This is demo for Module 5, where we discussed relationships between different tables. We understood the propagation of those relationships. And here we will be looking into a report that we created in Power BI Desktop, which is called Sales Analysis. And that's the one that we saw earlier in Module 4 as well. So as you can see, in this report, we can filter our sales for year 2021 by category of our product. So for example, we're displaying sales for accessories and we see different number. We're displaying our bikes and we see different number for the sales amount. And we have our chart also that is moving depending on the product category that we select. Now, let's take a moment and have a look at the model behind the scenes, which we saw in the previous module. It's a star schema design, which is the recommended design for our tabular model in Power BI. So we can see our sales table, which is a fact table, which is then also having all these dimension, product dates, etc. tables supporting our data analysis expressions in the background when we are using those different filters. You will also notice that we have the relationships that are set up between these tables. So for example, between sales order and sales table, we have a one-on-one relationship with both directions for the filter propagation. We have our product dimension table, which is having one-to-many relationship to our fact sales reseller table. And we see that the direction of this filter propagation is from the dimension product table to the sales table. Now let's expand the list of columns that we have in the product dimension table, and we'll notice that we have different information like product category, product key, etc. And we see that there is a common key that is relating those two tables, and we can see that this relationship is currently active. Now let's double click on this arrow, which is showing the direction for our cross filter, and we will see the cardinality type, the cross filter direction, and we see that we have this checkbox that is allowing us to make this relationship active. Now, for the sake of showing you what would happen if we did not have this relationship between our dimension product table and the sales table, which is our fact table, I'll simply uncheck this box and I hit the OK button, and I'll go back to our report. So as you remember before that, when I would filter based on this category for our product, accessories, bikes, clothing, our report would move. All these different histogram bars would move inside our chart, and we would see different numbers depending on the product that we're filtering for. Now, once I've removed that relationship, we will see that our report is no longer filtering based on the product category. Why is that happening? Well, that is happening because we just removed the relationship of our cross-filter direction from our dimension product table, which has all these product categories, and the sales table. So we are no longer capable to distinguish between the sales for different product categories. If I put back that relationship, if I put that back into active, and as you can see, when the relationship is inactive, we have this dotted lines here. So I'll double click on that. I'll put this relationship back to be active, and we'll see that when we are using the different filters on this report in Power BI, we will be again able to see different numbers. So as you can see, sales amount for bikes, sales is $28.54 million, and for accessories it's $138,000, etc. So we're again capable of filtering. So that is why it's important to properly design the relationships between the tables and the direction of the filter propagation. And as you can see, for some of the tables, we even have inactive relationships. And you might remember that in the module, we discussed that there are some DAX functions that will allow you using a specific relationship that is not active. So for example, between this date dimension table and the sales table, we have one active relationship, which is one-to-many, and we have a couple of others which are not active, and we can use them using the use relationship DAX function if needed. Let's look into knowledge check for Module 5. Are you ready? Question 1. Bell is a data modeler at AdventureWorks who is developing a model for a data warehouse. The model includes a table that stores products and another table that stores sales of those products. Bell adds a relationship to relate the two tables: one-to-one, one-to-many, or many-to-many. That's correct. In this case, we need a one-to-many relationship. Question 2. You're developing a data model in Power BI desktop, and you've just added a date table by using the calendar auto function. You've extended it with calculated columns, and you've related it to other model tables. What else should you do to ensure that DAX time intelligence calculations work correctly? Add time intelligence measures to the date table, add a date column, or mark as a date table. And that's correct. We always need to mark that table as a date table. Question 3. Joshua is a data modeler at AdventureWorks who is developing a model for a large data warehouse. The model must enforce RLS, and the Power BI reports that connect to the model should deliver the fastest possible performance. What should Joshua do? Apply rules to hierarchies, apply rules to dimension tables, or apply rules to fact tables. And that's correct. We need to apply the rules to our dimension tables. And with that, we have reached the end of the knowledge check for Module 5. I hope you enjoyed it, and see you in the next module. everyone, and welcome to Microsoft's Designing and Implementing Enterprise-Scale Analytics Solutions using Microsoft Azure and Microsoft Power BI. My name is Anna, and this is DP-500, Module 6, where we will learn how to implement advanced data visualization techniques using Power BI, and we will make sure that your reports look professional and the end users of your reports will be happy. Without any further ado, let's have a look at our module agenda. As you can see, we have only 2 lessons, where in the first one we will understand how you should improve your visual representation of the reports, because quite often you might have end users complaining about how the report is not looking professional or taking ages to load. So we will see what are the techniques on the visual side of things to improve those reports. And then we will speak about monitoring data in real time with Power BI, where we will be looking into a use case where we will be working with IoT sensors, and we will need to monitor those IoT sensors in real time using the Power BI dashboards and reports. So let's get started with our lesson 1, where we will understand how to use advanced data visualization techniques in Power BI. Often, when you are creating reports and you are publishing them, the end users, the consumers of your reports, the Power BI users, the BI stakeholders, they will be complaining that those reports may be slow, the visuals are not loading properly, and that's probably one of the most common complaints that you will get in terms of the graphical user representation of your report. And as an enterprise data analyst that is creating those reports, it's important that your report not only is loading quickly, but also looks professional. So we will be looking into techniques that will make your reports look professional. And some of them might seem even obvious to you, like the one that we see on the slide here, importing and creating a custom report theme. But that is something really important when you are working with Power BI reports and when you want your users to trust that report and to be attracted to that report. So what we suggest using and what we recommend, especially in an enterprise scale, is always making sure that your report color themes are friendly for color-blinded people. You need to think about the end user in the end of the day. And of course, you need to also respect the organizational enterprise coloring themes and logos, slogans. What do we have on this slide? On the left-hand side, we have a little screenshot from Power BI Desktop from the View ribbon, where you can see how we can easily choose one of the color themes that exist in Power BI. So one of the themes that all these themes that you see here, all these big tabs, those are themes that already exist. If you would like to personalize one of the existing themes and save it to share with other data analysts who are working on reports, you can do that. And with this red underlined portion here, browse for templates here, we're demonstrating that you can easily load a custom report theme that you have created previously or your colleague created, and you can work on that and load that report theme for your own reports and dashboards. What we have on the right-hand side, it's an existing report that is using custom color theme. And as you can see here on the top left-hand side, we are using some logo for this company, and we might guess that this is an electricity company. We see that there is a slogan of this company, and we see some specific color schemes, which are mostly in blue color lines, and we understand that this is their corporate theme. And this makes this report look professional. Especially when you look into logging later on as a Power BI ecosystem administrator, you might find out that these type of reports that look more professional are actually more popular because the users tend to use them more frequently, which will be meaning that basically your reports are successful and they are being used by the BI stakeholders, the end users. The templates that you can create, you can use them in the PBIT format, and you can simply load them and share with other stakeholders that are working on those reports. So that was one of the improvement techniques that you can deploy in order to make your reports look professional. Another technique that we recommend using, especially in an enterprise scale, where you have many users, you have many BI stakeholders, different teams, and the report, one single visual cannot please everybody. So you might give your end users, your report consumers, the possibility to choose and to personalize some of the aspects of the visuals within your reports. So on this slide, we're listing on the left-hand side the different types of visualization aspects that your end users can modify, customize if you enable that option in your Power BI reports. And on the right-hand side, we're displaying how easily they can do that from their Power BI report once they are in the Power BI service, for example. So as you can see, we can modify the visualization type. So what do we have here? On the right-hand side, we're having a column chart, and within this column chart, the clustered column chart, one of the users might be like, I would prefer to see a pie chart instead of a clustered column chart. And if you have, as a data analyst, as a report creator on an enterprise scale, if you have enabled the possibility to personalize the report, the user will be notified in their Power BI service environment that they can personalize this specific visual, and they can click on this button where they will see all the options of personalization that they can choose among. For example, they might switch to a pie chart or to some different representation of this visualization. They may modify a little bit the legend. They may remove or add some items in the legend. They may compare different measures. They may change the aggregations. And that might improve the user experience. And in the end of the day, your report will be successful and used by the stakeholders in your enterprise. Another important aspect when you are designing reports, on the visual side of things, you need to always consider your audience. You need to think what will be the most convenient thing for your report consumers to visualize from your Power BI reports, dashboards. What is the logic that they will adopt to visualize those items? So in terms of the audience, you might want to consider including an alt text, as suggested also on this slide. Now, what does that mean? That means that people with low vision, when they use a screen reader, they will be able to know what are the visualizations on that specific report or dashboard. So basically, the screen reader will use that alt text to read what's the title of your visualization. It's like having a little description of your visualization that will be pronounced out loud by the screen reader, and low vision people, or simply somebody who doesn't have full access to their screen, for example, they will be able to know what are the visualizations on your report. And although these little improvements can seem quite obvious, or you might not have been thinking about them at all, in general, those are things that will improve the user experience quite a lot. Another option that we have on the slide here, that's the set tab order. In Power BI, you can set up the tab order and the layer order. So those two settings, they are somewhat different. The layer order means the order in which you are clustering items on your report. The tab order is the order in which the keyboard readers will be going from, so if I'm using a keyboard to pass from one item onto another within your report, within the report that you created, my keyboard reader will be going in the order that you set up in the tab order. And all those little improvements will make sure that the end users are happy with the report. Let's have a look at other improvements that we can have. So let's imagine we're working on some reports and we're collaborating with data science teams. And those data science teams, they are doing some visualizations using Python scripting, R scripting, and those visualizations are going to represent, for example, some probabilities or statistical distribution of data sets, for example, financial data, or some data about sales, like probability to have this amount of sales, etc. Now, if you would like to show those visualizations on your Power BI reports and dashboards, you could actually include those visualizations, the scriptings, that custom visualizations into Power BI reports and dashboards. And with the R visualizations, you will need to also make sure that you have the correct version of R running behind the scenes, so there's some extra setup to be done before you can copy-paste the script and configure that inside your visual. For Python script, there is much less to configure. You can simply copy-paste the code and start working with that visual from your report. Now, let's imagine you have done all these improvements, you have configured all these little components of your visual aspects of the reports, and you want to publish it. Before publishing, make sure to not forget to use the performance analyzer in order to verify if your visuals are loading fast enough. because all those little aspects that we're doing in the visual side will depend not only on the amount of visuals that you are putting, etc., but the speed of loading of your visuals will depend also on background effects. So even if you have a perfect data model behind the scenes, please make sure to check with Performance Analyzer whether your visualizations are loading fast. And many reasons can be behind the scenes if they are not loading fast. If we are speaking on the visual aspect of things, please make sure that you are not using too many columns from your data set. You are not using too many visuals. If your data model behind the scenes is perfect, if you are, let's say, using direct query and the data source is optimized, and you are sure that the slowliness of the performance is not coming from the data source and DAX queries behind the scenes, then make sure that on the visual side of things you are also optimizing the performance according to what you observe in Performance Analyzer. And as you might remember, we had a look at Performance Analyzer. You just need to record a little bit of performance by using that start button. And once you have recorded that performance by moving to different report pages, by moving to different visualizations within your report, then you can analyze, stop the recording and analyze what happened and which visuals are loading slower or faster. And once you investigated that and once you're sure the report is loading fast, then you can publish that. So in lesson 1, we focused more on the visual aspect of things, how to optimize your reports on the visualization side. Now let's imagine that we're in a use case where we need to monitor IoT sensors. For example, we are in a smart city scenario and we have sensors that are saying how much space we have in parking lots or what is the temperature of some devices. And we need to make sure that that data that is ingested at a high speed with big velocity and big volume is going to be monitored in a Power BI dashboard or report. So we will be looking into how we can monitor that real-time data using Power BI in lesson 2. And quite frequently, in the use case that we just discussed, we cannot use direct query model. Of course, as in any case, we need to first start with understanding what are the requirements of our system. So with the IoT sensors, with the financial data like stock market changes that we really need to capture in the moment within a tolerance of delay of a couple of seconds. In those kind of examples, of course, we will need to use real-time data sets. In some cases, your end users, those could be BI stakeholders, those could be business users, they might tell you that they need real-time data set, but you might want to dig a little bit deeper to understand really what's the demand. Because in some cases, you can actually cover those use cases with direct query and automatic page refresh or automatic dashboard refresh features, which we will cover in a couple of moments from now. So you really need to understand first what type of data sets you need to use in the background. If the request for your tolerance in terms of the delay is on the order of seconds and up to 15 minutes maximum, in those cases we need to design our data set as real-time reports or dashboards in Power BI. So with IoT sensors, of course, we would go for real-time analytics. So what do we have on this slide? We have on this slide an illustration of how with a Power BI you can monitor in real time the information about, in this case, it's a server temperature. So we're monitoring that in real time. And in addition to that, with this numerical visual right below where you see the numbers going from 10 to 12, etc., we can see whenever the temperature of our server goes beyond a certain threshold that we set up, we will have this bar going red, which means that it needs some extra attention. So this is a real-time dashboard example where we can also have that alerting capability. And here we are using real-time analytics because the delay tolerance is really on the order of 1 to up to 15 minutes. If your delay tolerance is greater than 15 minutes, you can design similar behavior with direct query and automatic page refresh, automatic dashboard refresh. Let's take a look into example where the delay tolerance could be almost real-time, but could be modeled with direct query. Let's imagine your BI stakeholders are telling you that they need to monitor financial data, and those financial reports that they need to monitor will be updated by the end of each business day. And on the next day, they simply would like to see the data from yesterday. This use case can be completely designed with direct query model and with automatic page refresh in the reports and automatic dashboard refresh. So with automatic page refresh, the feature is quite straightforward. We need to use the direct query storage for our tables, or we can use a live connection if we're using SQL Server analysis services, and we can also use that automatic page refresh feature with a push or hybrid data sets. Now, with automatic page refresh, we can simply specify how frequently our page will be refreshed. So it's the auto refresh property that we can set, and there is another property that is available in the premium capacity, which is called the change detection feature. And with that feature, we're simply able to configure a threshold of the change. So basically, when there is a change in your data set compared to the last version of it, your report will be refreshed, but you need premium capacity for that specific feature. So with real-time dashboards, and by the way, the difference between real-time dashboards and real-time reports is simply within the fact that with dashboards, you can also create that alerting feature that we saw in the earlier slide. So in general, it's recommended to go for real-time reports because you have more features included there and more flexibility. But if you need that alerting feature that we mentioned earlier, in that cases, you will need to go for a real-time dashboard. So that's the difference between the two. Now, when you're creating your real-time dashboards, the types of data sets that are supported are these four. So streaming data sets, push data sets, hybrid data sets, and PubNub streaming data sets. And if you're not familiar with them, the PubNub data sets, they're usually used for monitoring things like weather changes, stock market changes, and the ones that are integrated with Power BI are the ones that are using the JSON format. And another feature that might be interesting for users that are using the paginated reports feature and rendering them in HTML. In those cases, you can use again this auto refresh of your report page for the paginated reports feature, which is in the order of seconds here. So on the slide here we have on the right hand side it says 60, it means 60 seconds. So if your paginated report is being rendered in HTML, you can actually use that auto page refresh feature there as well, which can come in quite handy for some cases. This is demo for Module 6, where we learned about advanced data visualization concepts and we understood how we can improve the visual representation of our reports to make them color blend friendly, to make them more attractive for end users, and to make sure that they use the organization themes, that they use color themes that are appropriate and representing our organizational color charts, and also for low vision persons, how we can make sure that the reports are friendly. So here, what we are looking at, we are opening a report which is called Sales Analysis, which we saw earlier in my Power BI desktop. As you can see, there is a specific color theme that is currently used on this visualization. And if I would like to change that color theme to a custom one, to one of the pre-existing ones, I would go to this View ribbon, and when I click on this little arrow, you can see that we have some predefined themes, and I can simply switch between these color themes, and my cluster chart is going to change the color. We can go into this one, etc. If we want to customize the theme, we can click on this Customize Current Theme button, and we will be able to select the different coloring options in here. For example, if I would like to use, instead of color one, a different one, we could simply, with this graphical user interface, navigate and in a similar manner change the text, the titles, the visuals, etc. Another option that we discussed in the module was browsing for themes. So using some themes that have been previously created for color-blinded friendly types of themes. So for that, I will click on this Browse for Themes button, and you will see that in here, I will have a theme that I imported, which is in this JSON format. And actually, this theme, I imported that from the gallery of different themes that exist on the portal for Power BI, and you can scan that portal and search for a different theme that pleases you the most, or that is the most convenient one for your organization. So here we have the color blended friendly theme, and as you can see, it has already been set up with different colors which are color blended friendly. They need to use different contrast, and as you can see, it's already done. I do not need to modify that. I imported another theme, which I will show you in a second. So I will go for this browse for theme and option, and I will click on this Power BI color theme University of Melbourne. So here I have a different coloring schema, and I can modify that as well and save that as a customized color theme. So let me switch back to that color blended friendly theme. Another aspect that we discussed in this module was how you can set up the tab order and the layer order. And as you remember, those two features are quite different, because layer order is the way we stack the different items within our report, one on top of each other. So basically layering them. Tab order is for keyboard users who will be watching our reports, who will be viewing them using a keyboard reader, and the way they will be logically guided throughout the different items within our report. So those two orders are different. Now let's see where we can configure them. So again, here we have our Power BI report, and if I go to this view ribbon, you will see that, I'll just switch off the filters, you'll see that we have this selection part in here, and when I click on that, we get access to the layer order and to the tab order. Now within the layer order, you will notice that we have all these different elements stacked on one on top of each other, and here we have the fiscal year, then we have the category year element, the slicers, which are stacked on top of each other. So let me first move the category onto the fiscal year, and let's now change the layer order to see what happens. For that, I will just select the slicer and push it below. As you can see in the report, in the layer order, my category will be disappearing then. So it will be underneath my fiscal year slicer. Another thing that we saw was the tab order. So let me just put this back. In the tab order, we're specifying the order in which these items will be scrolled using the keyboard reader, sorry. So fiscal year first, well, actually no, sales amount first, as you can see from this list. Then the second will be this card. Third one will be the slicer, category slicer, and then fourth one will be the slicer for the fiscal year. And you can actually hide some of the items from your report if you do not want to display them. So for example, this card here, we can hide that using this little eye icon, and we click on that, it simply disappears. In the same way, we can make the sales report, the visual, disappear as well. Another aspect that we saw in the module theory for this module, we looked into different visuals that you can use using the drag and drop interface in Power BI Desktop, such as R script visuals, Python visuals, and these are the ones that you can see here in the visualization pane. So when I click on this R visual, we have this little pop-up that lets me insert some script in here, and in the same way, if I wanted to rather use a Python visual, I would simply go to Python visual, and you can see here that I will be able to insert my script in here. And for Python script, we do not have that many configurations to be done except inserting our script, whereas for R, we will need to also have our version running behind the scenes. Another thing that we discussed in that module was the possibility to modify the report visuals from the Power BI service by the end users. So let's have a look into that. And for this, I will first load one of the reports that I have in my workspace here, and I will share that with you on the screen. And as you can see, in this Power BI report, we have allowed personalizing the visuals. As you can see, when I'm putting my mouse over on top of one of these visuals, we can see this button that says personalize this visual. So when I click on that button, I will see all those different options that will let me personalize this visual as an end user. So as an end user in this Countess of Vehicle Anomalies report, I would like to, for example, change this visualization type from map into a pie chart, for instance. And in that case, it will be displayed in this specific visualization. Then I can modify the legend. For example, I would like to see also the energy oil component in this legend. I would like to do some value computations, modify the values that are shown on my report. And I can also modify the tooltips if we have some tooltips and I want to have more information in the tooltip, for example, about the average speed. We will have that personalized, and with the tooltip we'll be able then to display that information about the average speed. If we want to recover the original state of this report, let's say I want to see what were the original visuals after I modified the personalizations. I want to remove everything that I've done. We can use this yellow button to reset everything, and you will see again the visualizations in their original state. In a similar way, if I wanted to modify to personalize the visuals here, I might click on this button on this specific visual, and again in the same way I will go to, let's say, this chart here, donut chart, and we can modify the legend. For example, we can remove this field, we can add some fields. For example, I want to add the speed here, and it will be showing the speed. I can compute some values, I can modify the details, etc. So again, once I'm done and I no longer want to see my personalizations, I will simply reset everything to the default values of this report. So with this, we are reaching the end of Module 6, where we learned how to deal with the visual aspect of things in Power BI reporting on an enterprise scale. We looked into how to make your report look professional and use corporate color themes. We looked into how you can leverage color-blinded friendly themes, how you can use different tab order settings, alt text feature in order to make sure that your readers, the report consumers, will have a more user-friendly experience and they will like your report, how it appears, and they will be happy in the end of the day with the reports. We also looked into several personalization features, how you can make sure that your end users can even personalize your reports and the visuals on them. We then looked into a different use case scenario where we spoke about IoT and sensor real-time streaming data sets. And we spoke about how you can model those data sets in order to monitor them in real time with Power BI. For example, if you are using a smart city scenario and you need to monitor the weather changes in real time. We also mentioned the difference between real-time data sets and the difference in cases where you can model near real-time performance with delay tolerance above 15 minutes using direct query, for example, and automatic page refresh, automatic dashboard refresh features in Power BI. And we'll also looked into what's the difference between Power BI real-time streaming data sets and the reports that you can use with those data sets versus the dashboards. With this, I will see you in knowledge check question and see you later. This is the knowledge check for Module 6. Are you ready? Question 1. What's an inclusive benefit of designing a report with accessibility features? A. Users don't have to autoplay videos slowing the performance. B. Users will admire the bright colors and decorative images using for cohesiveness. And C. Users can understand the report using a screen reader or keyboard. And the correct answer is, that's correct. Users can understand the report using a screen reader or keyboard. Because the main goal there is not only to make the users admire or love our report, but of course to facilitate their journey throughout our report and to make sure that they are able to understand easily, no matter which tool they are using, which hardware they are using to visualize the report, and no matter what low vision troubles or any other troubles that might have. Question 2. Gladys is a developer at AdventureWorks who needs to create a real-time Power BI solution to monitor their call center. When there are excessive numbers of callers waiting on hold, Power BI should notify the call center manager. What type of Power BI artifact should Gladys develop? A. Dashboard. B. Power BI report. And C. Streaming data flow. And the correct answer is a dashboard. Now, why a dashboard? Because as we discussed earlier, we need to make sure that the alert can come up on the visual, because in our requirement in the question here, in the use case, we need to notify the manager when a specific threshold of our calls has reached its limit. That's why we need to create the dashboard to make that visually obvious to our manager. Question 3. Fiafe is a developer at AdventureWorks who needs to deliver a real-time Power BI dashboard. It should present a real-time manufacturing data with the lowest possible latency. The dashboard only shows manufacturing events for the past hour. The solution should use the minimum of Power BI resources. What type of dataset should Fiafe develop? A. Direct query dataset. B. Streaming dataset. Or C. Push dataset. That's correct. We need to work with streaming datasets for this use case. And that was our last question for Module 6. I hope you enjoyed it, and I'll see you in the next modules. Hello everyone, and welcome to Microsoft's Designing and Implementing Enterprise-Scale Analytics Solutions using Microsoft Azure and Microsoft Power BI. My name is Anna, and this is DP-500, Module 7, Part 1, where we will be discussing how we can implement and manage an analytics environment. Let's have a look at our module agenda. In this first part, we will be speaking about providing governance in Power BI environment, where we will get introduced to the main three types of stakeholders that are in charge of maintaining a healthy Power BI ecosystem in an organization. In further three modules, which is lesson 2, 3, and 4, we will be talking about how you can implement those portions of Power BI ecosystem governance using the different configuration settings within your Power BI tenant portal, admin portal, and many other settings. So, for example, we will be speaking in lesson 2 about facilitating collaboration and sharing in Power BI between different stakeholders. We will then speak about monitoring and auditing the usage of your reports, which is more on the central IT side of things. And of course, we will be speaking about procurement with Power BI licensing. We will be seeing into how premium capacity could be useful in an enterprise analytics environment, and how you could be leveraging those functionalities as a central IT role or as a Power BI admin. The last 3 lessons that we see on this slide will be covered in the part 2 of Module 7. And there we will be speaking about establishing a data access infrastructure in Power BI, broadening the reach of Power BI, and automating Power BI administration. But for now, let's start with part 1. So let's see lesson 1, providing governance in a Power BI environment. And in general, Power BI governance is typically a set of rules and policies and regulations that will define and ensure that your Power BI ecosystem is functioning as you would like it to be, and it will be a valuable representation of your data assets, and they will be used as they are supposed to be used. Now let's have a look at the main key 3 groups, stakeholders that are going to be responsible for maintaining that Power BI ecosystem. Where I have grouped here on the slide on the left-hand side the IT BI teams, business users, and central IT. In different organizations, they can be called differently, but overall their roles are quite similar, and the groupings will be similar. So IT and BI teams, those stakeholders, they will be mostly responsible for creating a set of regulations, rules, and policies that will be telling how the data will be collected, cleansed, and also cataloged, how the cataloging of your data will happen in an organization. They will also be responsible for saying what type of reports will be used across the organization and how they will be used between different stakeholders. The business users that we see on the slide here, they are going to be mostly collaborating and understanding how we can reach a common goal. What are the different metrics that we are trying to evaluate within reports? So they are mostly going to be researching the different requirements for our BI reporting. And finally, the central IT role, as you can see from the slide here, has quite some responsibilities. So first of all, of course, that will be training and education of all those different stakeholders within our Power BI ecosystem to make sure that users, be it data analysts, report creators, or the final report consumers like BI stakeholders, know how to use those different data assets, know how to use the reports, know how to get some help, because that's a key to a successful deployment of your BI ecosystem. We will then see that the central IT role also is responsible for data governance. That means that they will be defining policies, rules in order to set those data governance techniques. And they will be also responsible, this third portion here, is enabling business processes and access control. That typically means granting users access to the system and making sure that they can make use of that system. They are going to be defining what can they access within the system once they have been authorized that access. And the final part of the central IT role will be procurement and administration. Procurement and administration simply means that we are purchasing elements of our Power BI ecosystem. Those could be, for example, license procurement. Those could be some other elements that are necessary for making our Power BI environment functioning. In general, when we speak about data governance, there are three major elements. We first need to be able to have a visibility of the system. Secondly, we need to have the control over our system, which means that we need to make sure that the policies that we are enforcing for the use of the system, for the way that data is going to be used and distributed, the reports, and how the different stakeholders are interacting with those components, those policies need to be ensured and be surveyed and controlled to make sure that they are being actually deployed. And finally, the compliance portion of things will be making sure that all of the different components are working in a uniform environment and everything is compliant to the different policies that are set on the different levels, data governance, accesses, etc. In order to configure some of those elements that we touched on in the previous slides, let's have a look how we can do the environment configuration in our admin portal from Power BI. So in general, when we go to the admin portal, we need to be a Power BI administrator. So we do need to have that administrator privilege, and we will be able to configure different settings from that portal in order to enable them on an enterprise level, or we can disable them on an enterprise level, which means that all of the users that are going to be leveraging your Power BI assets, reports, dashboards, etc., they will be able to do some of the features or not to use them. And finally, we can enable or disable that features to a subset of the organization. For example, some of the buttons might be available for sales team, but not for the marketing team. And within the admin portal in Power BI service, you can actually configure those settings. On the right-hand side, we see the workspace settings within the admin portal, where we're configuring the workspace, whether we allow our users to create workspaces or not. So this feature is enabled, and as you can see, it's applied to the entire organization. That means that everybody within our organization will be able to create workspaces in Power BI service using the new workspace environment. Another commonly disabled feature, which by default is disabled but could be enabled for some subset of stakeholders, is the Publish to Web button. You might have noticed that button if you are using the Power BI service, and in some cases that might be simply missing. Well, that depends, of course, on what has been configured in this admin portal settings and whether the admin of your ecosystem of Power BI is allowing that setting or not. By default, it's turned off. And that can be a handy feature if you want to share your reports or some assets with other stakeholders or even on social media. But in terms of data security, that might be a vulnerability. That's why it might be disabled on your organization level. Another interesting feature in terms of the organizational configurations on an enterprise scale, whether we're allowing them or not, we can actually make some specific visuals, PBI viz files, available on an enterprise level. And that can be even visuals that have been disabled for your tenant or blocked for your tenant, but as an administrator of your Power BI ecosystem, you can add some custom visuals, even if they are disabled by default for the whole organization. Another aspect of enabling things is once you have published to web some of the content. So we imagine that Power BI Administrator lets you publishing some content into social media. As an administrator, you can still manage those assets that are published. As you can see here on the right-hand side in the admin portal, in this embed code section, we can see all the different embed codes and we can manage them, whether we want to disable them or not. So we can actually use them with caution, and as a Power BI ecosystem admin, as the Power BI admin role, you can disable those codes if you think that they are presenting some vulnerability. There's a very good best practice that we recommend always deploying as a Power BI admin and the user that is responsible for maintaining that Power BI environment. We always recommend enabling the Get Help button inside your Power BI infrastructure, which means that the users, the BI stakeholders, report consumers that will be accessing Power BI service, they will be able to see that button, Get Help, and they will be able to get information about extra documentation that will be available for them when they are blocked. And this is actually also leading to very good user experience, because when we are blocked, especially on an enterprise scale, when we have too many reports, we might not always know who's the person to contact if we are not sure about something in the report, if we don't know how to interact with that report, or if we are missing some documentation. And if you enable that on the tenant settings on an enterprise level, you will have that button for all of the users in your system, and you can also additionally enter some URLs in here, as you can see, for training documentation, for discussion forum. And for discussion forum, typically on an enterprise level, that would be Microsoft Teams, for example. Quite frequently we're tending to go into a channel in Microsoft Teams and search for documentation there, or search for some discussion with our colleagues. So you can put the channel URL in here for your discussion forum. But of course, you can leverage any discussion forum that you are using most of all, that the stakeholders in your system are using most of the time. And again, this can be applied to the entire organization or to a specific security group, but overall it's a good practice to enable it for everybody. Another aspect that we're going to be looking into is this lesson 2, facilitating collaboration and sharing in Power BI. So let's imagine we've created our dashboards and reports, and we want to collaborate with our colleagues because we have multiple report creators, and we need to make sure that all those teams can collaborate in this unified experience. So what would be the best way to share with them those reports, and to see also, to let them work on those reports as well in parallel? Well, there are two types of workspaces in Power BI service. And you might have noticed that when you go to the Power BI service, you will notice that you have My Workspace and you have other set of workspaces. What is My Workspace? My Workspace is simply an environment where you can test your reports. For example, if I'm trying to set up a report and I want to test out how it will work, how it will look, I can publish it to my personal workspace for testing purposes. Then I might change some things, republish it to my workspace. But that workspace should never be used for actual production environments or for sharing with other users. And the reason for this is because my workspace is attached to your user, to your identity. So if that person leaves for a vacation, changes company, and that reports stay in my workspace, those reports will no longer be accessible, and they might even get lost once the person goes from the organization. So it's always a good practice to publish your reports to shared workspaces. So shared workspaces are the ones that you see on the slide here, and we're demonstrating here a Power BI service environment where you have all these different menus on the left-hand side, and under My Workspace you see all the different shared workspaces across your organization. For example, here we have a workspace that is called Customer Profitability, IT Spend Analysis, Human Resources, and those reports, those shared workspaces can be used for sharing reports and different assets within those workspaces, and different data analysts and different data report creators can collaborate from that workspaces. So you should always use the shared workspaces. Whenever we speak about sharing, especially when we're talking about Power BI environment governance, when we're speaking about roles like Central IT, Power BI Administrator, we always start thinking about security of things. Am I supposed to give enough access to those stakeholders to collaborate, but also to limit those rights in some way. So for that reason, we have the workspace roles. And whenever you are sharing that experience across workspaces, as a Power BI admin, you can configure the different workspace roles. And of course, as the names are obviously suggesting to us, viewer will be only able to interact with items, but he or she will not be able to share them, to contribute to them. Contributor will have slightly more rights, but so they will be able to share reports, create a report in another workspace, but they cannot add members. Members will be able, in addition to the rights that they get with contributor type of role, they will also be able to add members that have lower roles, lower permissions. And administrator, as the name suggests, they will be able to fully handle that workspace, delete that, update that, and also add different members. Another important aspect of our Power BI environment, especially when we want our teams to collaborate, the data report creators to share assets, is using apps in Power BI. And apps typically is just a subset, is a group of different assets. Those could be data sets, those could be different reports, dashboards that you want to share in one single sharing experience with your users, other stakeholders. And whenever you are using app sharing in Power BI, you can actually use the different custom themes. And here we have a little screenshot demonstrating that you can name your app. For example, if you're sharing some reports, data sets with some sales and marketing team, you can name your app in a way that it will describe what teams you are sharing it with. And those stakeholders will be able to interact with the items within that Power BI app. So there are two possibilities to share. When you are sharing inside the organization with the users, with the identities that are within your tenant and organization, those users will be able to view with the items with those apps, but they will not be able to edit them. If you are sharing them outside your organization, you will be able to, the people outside your organization, they will be able to view and interact with those items, but they will not be able to share it with other stakeholders. When we're embedding data into different social media, so we're speaking about that publish to web button, that could be a very good experience for your users to be able to share those reports into some websites or into some portals. But of course, the embed option will not automatically allow users to view the report. You need to set up some extra permissions for that. Whenever we speak about sharing, we need to also distinguish the different types of data privacy. So is the data considered to be a private data source? Is it an organizational data source, or is it a public data source? We have the more formal definitions on the slide here, but you can actually imagine the private data sources, any type of information that is speaking about personal information, like Facebook information of a person. Those could be some data about employee information. Those could be employee review, employee personal address, employee personal number. Organizational data source examples would include, for example, some SharePoint document that is shared across organization, for example, within Microsoft, but those are those documents have some permissions enabled only for the users within the organization because it's talking about some organizational data that is not publicly shareable. And public data sources, those could be, for example, Wikipedia pages, some articles that are publicly available and they are not subject to any NDAs or organizational type of information limitations. Once we have enabled the sharing across the different stakeholders of our data assets and reports across Power BI, now let's have a look in lesson 3 about how we can monitor and audit the usage of our reports. Because as you might remember, an important element of data governance is also to understand how those assets within Power BI ecosystem are being used by the different stakeholders. And sometimes, as surprising as it might sound, it's more important to realize what is not happening in your system rather than what is happening. And what do we mean when we say that? in Power BI service, you might have noticed the usage metrics for dashboards and reports type of report, which you can generate automatically, and it will give you an insight on how your reports are being used, which of the reports are being more popular, how frequently users are tending to view them, etc. And as a Power BI ecosystem administrator, you might be interested also to see which ones are the reports that are never being used, which may mean that either the report is not very useful, or it's not, the stakeholders simply cannot find it, or the report is not visually looking professional, or the stakeholders are not trusting that report. And then you can investigate and take that investigation further and finally modify that report to make sure that it's being used, or maybe simply remove that report. This report that we're looking into on the slide, this usage metrics report, that is something that you can actually personalize by using the Save As button. So by default, this report that you generate, it's read-only, but whenever you click on that Save As button and you save it as a personalized report, you can then customize the visuals on this one and use them later on with this custom setup. Another aspect of logging, whenever we speak about logs, we think about understanding and tracking user activity. And this is an important part of a Power BI ecosystem environment governance. As a central IT role, you might be interested in understanding what are the users doing, how the reports are being used, but not only the reports, also how the data sets are being reported, what is being shared. So basically, more of a traditional user tracking activities in audit log environment. Now, the audit logs that we see on this slide, those are the O365 global administration logs. So this is more of a unified environment, not only exclusively reserved for Power BI logs, and you can search them. So as you can see from the graphical user interface, we're able to search, to filter. It's quite a personalizable experience. But for that, you need to be a global admin. Now, if you would like to have this similar environment, the similar logs, but only for Power BI, you can actually use the activity log. And this is a relatively new feature, which for now is still lacking. For example, the graphical user interface might be lacking some of the things that we saw in the previous slide with the filtering and search capabilities. But overall, that's really the same information, but exclusively about Power BI that you would find in Unified Audit Log. So it's only Power BI auditing events, and you no longer need to be an admin in the O365 environment. You need just to be a Power BI admin to view those logs. So once we have seen how central IT can investigate logs and track user activity, we will touch on the last part of the responsibility for our central IT role within a Power BI governance ecosystem, which was, as you remember, the procurement of Power BI ecosystem elements, and those could be procurement of licenses. Now, in Lesson 4, we will be looking into the advantages of premium capacity, what are the different aspects of provisioning premium capacity, and we will be looking into also how that works in the backbone, like what we should imagine when we say premium capacity. And why do we speak only about premium capacity? Well, that's because we, as you might remember, we mentioned that in an enterprise scale, we will be working with big amounts of data, trillions and billions of lines within our tables, and we need to make sure that all the different reports that are using those gigantic data sources are going to be scalable and flexible. And premium capacity is really made for that enterprise type of environments with enterprise scale. And in addition to that, with Power BI Premium Capacity, we will have some extra functionalities and extra features that will make the user experience and the configuration experience even better. So let's first look into some introduction with understanding what does the premium capacity mean in reality. You can imagine the premium capacity of Power BI as having a dedicated virtual machine behind the scenes that will be having dedicated capacity, that is to say, dedicated memory, dedicated CPU, dedicated storage for your tenant only. And we also have the support for larger data sets, as you might remember from our previous modules. So we have resources reserved only for our tenant, and we can also investigate the usage of those premium resources within our tenant. Is the CPU being overutilized? Is our memory being overutilized? how much of the data source eviction we're having in the system. And by the way, about the data eviction, that is a feature that will enable your Power BI push out data sets that are not used by your reports for the current time being from the memory into the storage. And in some cases, you might notice that the data eviction rate is really high. But that does not mean that it's a bad thing. So what happens in the background in Power BI? You have all those different data sets that you connected to using the import mode or any other storage modes. And when your users are refreshing reports, when they are refreshing visuals, some of those data sets are going to be actively used. So the ones that are actively used, they are pushed into the memory, into the RAM of your imaginary virtual machine behind the scenes. But when your reports are no longer using those data sets, instead of overutilizing your memory with data sets that are not really being used right now, Power BI will simply push them into the storage. So data set eviction rate is not really a bad thing in that sense, but it could become a bad thing if you were using, let's say, a shared capacity, a Power BI Pro licensing. And in those cases, since you are using shared capacity, you are no longer using the memory by yourself alone. That means that if your data sets are evicted quite frequently simply because you don't have enough memory, and your report users, your visuals are requiring to update those data sets quite frequently because they are refreshing the reports, the visuals, etc., then it could result in a slow performance, and with other capacities that might be a bad thing. But with the premium capacity, it simply means that Power BI is managing the resources behind the scenes. Among the advantages that you can get with Power BI Premium is that you no longer need to use only the geographical region which is in which you have your tenant. You can use the multi-geography data centers for your different assets of Power BI. Another advantage is the bring your own key or the customer managed key feature, which you can use with Power BI Premium capacity, which means that whenever and in Power BI, as in most of the services on Azure, we're going to be encrypting the data at rest and data in transit. But usually we use default Microsoft managed keys. If you would like to use customer managed keys or bring your own keys, you can do that with the Power BI Premium capacity. There are a couple of limitations which you need to take into account when working with the bring your own keys, and you can see them mentioned on the slide as well. And finally, some of the external tools, which we have seen briefly in another topic in earlier modules, the tools that you can also leverage to investigate your performance whenever you are in premium capacity as well. Some of them are available also in other capacities, but ALM Toolkit is available with Power BI Premium. And for Tabular Editor, for example, we have seen already which aspects of your Power BI you can improve with Tabular Editor. It's more of a proactive tool that will give you some suggestions in the best practice analyzer, how to better use your Power BI, what could be a potential problem. DAX Studio is a tool, it's an open source tool as well, which will let you work with the DAX queries to improve your DAX queries and also investigate the performance of your DAX queries. Are they spending too much resources, on which side, etc. And ALM Toolkit is an open source schema compare tool, and that can be used for comparing the Power BI data sets. With that, we have reached the end of Module 7, Part 1, and there will be a knowledge check for this section. Please don't forget that. I'll see you in the knowledge check. This is the knowledge check for Module 7, Part 1. Are you ready? Question 1. Which of the following is not a common component of an effective Power BI governance model? Data engineering, service and support, enterprise reporting. That's right, the correct answer is service and support. Both data engineering and enterprise reporting are parts of a BI governance model. Question 2. In which of the following ways can you provide access to workspaces? Security groups, O365 groups, or all of the above? And the correct answer is all of the above. Question 3. What's the easiest way to convert a usage metric report into a full-featured editable Power BI report? Run the report through the Power BI report converter, use the Save As command, or set up your report request to render an editable Power BI object. That's correct. The right answer is use the Save As command. With that, we have reached the end of our knowledge check for Module 7, Part 1, and I'll see you in the next modules. Hello everyone, and welcome to Microsoft's Designing and Implementing Enterprise-Scale Analytics Solutions using Microsoft Azure and Microsoft Power BI. My name is Anna, and this is DP-500, Module 7, Part 2, where we are talking about implementing and managing our analytics environment. In the previous portion of this module, we have been looking into different aspects of governance of Power BI models, such as what are the main stakeholders that are participating in maintaining that Power BI environment and ecosystem. What are the different aspects of Power BI that we can configure those parts in? What are the different monitoring and auditing tools? What are the different premium capacity features that you can provision for an enterprise scale analytics as a Power BI ecosystem admin? In this portion of the module, we will be talking about establishing a data access across the infrastructure in Power BI. Then we will speak about broadening the reach of your Power BI apps and reports and how you can incorporate them into stunning visuals, into some kiosk applications, and what are the different prerequisites and best practices related to that. And then finally, we will be talking about some administrative tasks, redundant tasks that you might want to automate using some Power BI classical automation tools. And again, there we will be talking about some of the best practices that we recommend to adopt when working on an enterprise scale. And please keep in mind that some of the portions of this module will be accessible, some of the configurations, they are accessible if you are Power BI admin. And as a data analyst on an enterprise scale, you might not always be an admin. So some of the aspects will be more of recommendations or just for you to know where those configurations exist. But of course, you need to also have that administrative privilege for most of them. Without any further ado, let's look into Lesson 5, where we will be speaking about establishing a data access infrastructure in Power BI. And in this lesson, we will be focusing mostly on the different connectivity modes using the gateway, in an enterprise mode or in a personal mode. And we will see what are the best practices related to each of those different modes, and what are the different connectivity mode limitations, and what are the connectivity modes available at all with those gateway options. Before jumping further, let's first have a look at a little recap about what type of connectivity modes we had in Power BI. We have looked into them in previous modules, so first one, as you might remember, is the import mode. And we had a great level of flexibility with import mode because we can connect to the multitude of different sources that you want to connect to from Power BI. In terms of the limitations, we had the limitation on the amount of refreshes for our data sets per day and on the size of the data set once it has been imported into Power BI. And even though those values differ for premium capacity and for other licensing types, but still there is this limitation. Another connectivity mode that we have been looking into, that was the direct query mode. And with direct query, we are no longer limited in terms of the amount of refreshes or the data set size, because we're connecting directly to that data set, but we are limited in terms of the sources, data sources that support that type of connectivity mode. And there are also some other limitations depending on your data set, data source size, and how the indexing is organized in the data source, etc., etc. We also had a brief touch on the live or exploration mode, which is mostly used for SQL Server analysis services, and that's quite similar to direct query, but the only source that we can support with live connection is the SQL Server's analysis services. And with the composite mode, which was the last mode that we touched on in the previous modules, that's the mode that will be combining import and direct query modes together, their advantages, and will be benefiting for boosting the query experience for the direct query mode. Now let's imagine that we need to connect from on-premises data source, such as a SQL server in an on-premise environment, to your Power BI. In order to do that, you might need to have a secure transfer between your on-premise environment and your cloud environment in Power BI. So for that, you might want to configure an enterprise gateway. And there are two types of gateway connectivities that you can use in Power BI. As you can see, we're detailing them on the slide on this right-hand side. And there are differences that are summarized between the two connectivity modes in between those two different gateway types. So the one on the left-hand side is the gateway in the personal mode, which is targeted to use cases where you have only one data analyst working on reports. So you will have only one person accessing your Power BI environment throughout that gateway. The other gateway, or the bridge mode that we have, it's the enterprise gateway, which is not exclusively available for Power BI only. It's also available, as you can see here, for a multitude of different other services, such as Microsoft Flow, Power BI, Power Apps, etc. And in general, with on-premises gateway, you can give access to multiple different stakeholders, BI admins, multiple users that will be connected to your environment throughout that secure bridge connection. Now, once you have chosen your gateway mode, we will be mostly focusing on the enterprise gateway in the further slides. But basically, the connectivity modes in Power BI will be also different depending on whether we are using a gateway or not. So when we are using a gateway, in terms of the connectivity modes, we support import mode or the direct query or the live connection. So they are classified in the same category because they are quite similar and they are both supported. As you can see from the summary on the slide on this table, again, we have similar limitations in terms of the schedule amounts for the import query, import mode. We have the capacity limitation, we have the amount of refreshes, etc., that are limited, and similarly, direct query or live connection will be having similar advantages and similar limitations as we would have in a non-gateway environment as well. It's just that these two are the ones that are supported when we are using a gateway. Another consideration that you might want to look into is the amount of data the amount of data that you are going to connect to from Power BI when using the gateway. So you might want to look also into the documentation at docs.microsoft.com in order to find out what are the different limitations in terms of the size. Another important aspect of gateway connectivity mode is you need to take into account network requirements. On this table in the slide, on the right-hand side in the slide, we're summarizing some of them. So what are the ports and different URIs that need to be enabled from your environment in order to make that outbound connections? However, in general, you might want to have a look at the documentation to see and to work this through with your IT department. For example, that could be the central IT role that will be working, collaborating with you on that stuff, because it will need also the infrastructure behind the scenes supporting all those connectivities and opening those ports and URIs, etc. Technically speaking, Gateway is just a little software that you are going to be installing in your own premises environment, and you will need to also to pick carefully what is the machine on which you are going to be installing that environment, what's the memory, what's the CPU for that machine, and also that network requirements. You might not really install the Gateway on the same machine where you have hosted, let's say, your SQL server in the on-premises environment, but you will need to install it as close as possible to your cloud-based sources so that there are not too many nodes in between the two. And finally, what we see on the slide here, as you can notice, there's this download.microsoft.com URI that needs to be opened with the port HTTP, the AT port, because we're going to be downloading the gateway as a starter, and then we're going to be doing some upgrades, etc. So all these portals they are required to be opened within your firewalls and any other network restriction rules that you might be having on your own premises environment. Now, as to the question, where should I be installing my gateway? You can start, and on the slide we have an example of where you could start from, but overall you might need to consider also the overall environment, and you might want to also take into account how much data sources you are going to be ingesting and how much memory you might be using on that gateway. So as a starter, you can start off with 8 gigabytes of RAM with a 8-core CPU machine, and you will need to have a 64-bit version of Windows Server 2022 or later. Another option with the gateways, when you have large-scale, enterprise-scale deployments and you want to do some load balancing and you don't want to have one single point of failure, what you could do is you can establish the gateway clusters, which means that you will have a set of gateways within that cluster that will be available for load balancing purposes, and that will take over the charge whenever that other gateway is not available, or whenever that other gateway is overloaded. And on this screenshot, we have the little demonstration of how you would be installing one of the steps within the installation and adding a member to that cluster. And you will also need to use this recovery key. With the load balancing, you need to take into account that whenever you will be doing some operations on the gateway, you will no longer be able to see individual gateways within a cluster. So most of the operations will be directly applied to the cluster directly. So that's a consideration that you might want to take into account if you are on the central IT side of things. And finally, as an IT infrastructure management operation, you might want to also have some monitoring of your gateway documentation. So how your gateway is performing, some logging about your gateway, how is it doing. And there is some documentation available on our websites, and you should be using that as a reference whenever you need to have a look at some logging, especially if you are working with all the different types of logs that you can see outside in this slide on the right hand side. Please make sure to have a look at the repository of documentation. Another limitation that usage of gateway will impose is the amount of the data sources to which we can connect. What we are demonstrating here on the slide is the possibility to connect to the same source using different schema. As you can see here, we are connecting to AdventureWorks 2017 with schema A and with schema B. But you might want to check out all the different limitations that you will have in terms of the data sources and connectivity when you are using gateways. And finally, in terms of the gateway considerations, we might want to consider the user permissions and roles, of course, what we can do. So in terms of the user permissions, we will have admins, which will have, as the name suggests, and as you might guess, it will have the full control of our gateway. It can add other admins, etc. So full control of our gateway. We will have users that will be able to use our gateway to create connections, but they will not be able to share the gateway with other stakeholders. And finally, the last category of users that you can create to manage the permissions for our gateways is the users that can use and share the gateway with other users. So now let's have a look into lesson 6, where we will understand how we can broaden the reach of Power BI and how we can create stunning visuals and broaden the reach of Power BI into different applications, third-party apps that we might be developing using some REST API. In general, when we are speaking about REST API custom development, we will need to first be able to have those packages that will enable us to speak to our different apps. And for Power BI developers, there are different options available. So first of all, you will need to somehow establish the connection from your application that you are developing into Power BI. So let's say if I'm creating some mobile app that is going to be also incorporating one of the reports or Power BI apps that we created in our Power BI environment, and I'm going to be using REST API, in those cases, I will first need through that REST API to authenticate myself to the Azure Active Directory. And there are lots of NuGet packages and Azure Active Directory authentication libraries available for all those developers out there who want to establish, first of all, the connection and then develop applications that incorporate the Power BI reports inside their apps. Another thing that we will be using, of course, we will need some .NET SDK packages to be able to create our code, to communicate with our reports, to ingest them into our third-party application that we're developing. And again, within the NuGet repository that is available on the website of NuGet packages, you can directly get that Power BI.NET SDK packages and leverage them in your apps. And if you are more of a JavaScript developer and you are using the JavaScript SDK, we do have also some packages for JavaScript that will let you incorporate Power BI reports inside your JavaScript type of applications. Another option when you are trying to incorporate stunning visuals into your apps is to use the Power BI embedded capacity, because that one is better suited for custom development. And with Power BI capacity, you will need to create that in Azure portal and then assign that in Power BI service, and that will enable you to have all those beautiful visuals inside your different applications. Another aspect of broadening the Power BI ecosystem and using some artifacts that can be reused later on, that's the creation of data flows that we discussed earlier, but here we will be recapping them a little bit and reminding ourselves what were the main functionalities of data flows and how it can help us in all those redundant tasks, especially if we don't have any data warehouse behind the scenes. So with the data flows, as you might remember, those are just like tables that will organize the data into rows and columns, but they are going to be reusable. And they can be handy when you do not have any type of data warehouse behind the scenes, which will deploy also, in addition to that, the ETL and ELT transformation logic with your data sets. And this will not really replace that data warehouse in the cloud, but it will help you out in reproducing that logic inside Power BI and not doing the tasks redundantly. Now, what happens behind the scenes when we're creating data flows? And we have a screenshot in here that is displaying how you can create entities, how you can create a data flow, and how you will see that then appear in your Power BI service on the web page. You can see here on the background, the little screenshot behind, there is this data flow that we can see, and eventually this will result in reproducing that logic to later on provide you with the reporting capability in a more simple and reproducible fashion. Now, what happens behind the scenes? And we did touch on this in the previous modules, but this is a little recap of what happens behind the scenes when we're using the data flows. So we are having different data sources that we're going to ingest inside our Power BI, that we're going to connect to, and we also need to transform those data sets. So when we're refreshing those data flows and when we are ingesting all these different data sources inside Power BI right before, what happens in the background, there is an Azure Data Lake storage account Gen 2 that is created, and those transformations, those linked tables will be updated behind the scenes in that storage account before it is then brought into data sets in Power BI, and then it results in reports and those dashboards that we are creating within Power BI. In order to create data flows, there are multiple ways, and they're mentioned on this slide here. But you need to keep in mind that some of them will be available only with Power BI Premium capacity, and some of them will be available for most of the other capacities that you will be using. And here we have this demonstration of all the different options that we have the premium capacity. So those are the extra options that we will be able to use with Power BI Premium. Another way to broaden the reach of your Power BI apps, especially if you want to publish dashboards or some of the pre-packaged artifacts of Power BI that you want to share maybe with some of your colleagues or some of the other stakeholders within the organization, you can actually create the template apps which will let you visualize them in the app results when you are searching for Power BI artifacts from the app source, from the App Store, and you will be able to install them as a pre-packaged dashboard, which will enable the ease of installation of those dashboards, and you will not have to reconfigure that. Now, if you are more on the central IT, on the administrator side of things within the Power BI governance ecosystem, you might also be taking into account what are the template apps that are being used across the organization. You might want to also establish some kind of a governance and control over who can share template apps and what type of template apps can be installed or can be found within that App Store portal and used later on within your tenant. So the governance part of things needs also to be there. So now let's have a look into lesson 7, where we will be speaking about automating Power BI administration. So again, within the Power BI ecosystem, as you might remember from the part 1 of this lesson, of this module, we discussed what are the main responsibilities of the central IT. And one of those responsibilities was also the procurement of the Power BI different artifacts of the elements of this Power BI environment. Now, in order to do that, some portion of it will include procurement of licensing, some portion of it will include provisioning of artifacts within Power BI. And as an enterprise data analyst, you might not always be doing this kind of stuff. It's more on the administration side of things, but you need to know and be aware about these options that the administrators can use. So in order to provision to work with Power BI, we can use the REST API. So we can use the endpoint and communicate with it freely, and you can have all of those functionalities that are mentioned on the slides. And this is not the exhaustive list. Actually, you can have a look in the documentation in order to see what other REST API methods are there available, for example, to manage your gateways, to work with data flows, to work with data sets throughout the REST API. So if you are more on the development side of things, if you are administrator who is mostly using the REST API, then you can use those REST API calls and methods in order to work with most of these operation groups within Power BI. So when we are working more with PowerShell tools, we will need to provision resources, work with different aspects of Power BI using the Power BI CMDlets. And those CMDlets are basically just packages that you are going to find on the website of Microsoft PowerShell that you need to enable in your PowerShell before you are able to run some of the commands. So for example, if we need to work with data flows in of Power BI from within the PowerShell environment, you'll first need to have the component within your PowerShell installed on your local machine in order to be able to work with those commands and methods, to invoke those methods within the PowerShell from Windows. So typically when you are working with Power BI CMDlets, you will first install that, then log into Power BI. You always need to establish the connectivity with your environment, with your tenant from the PowerShell in this example, and then you can get information about workspaces. So all these 3 aspects that you see on the slide, they're available as Power BI CMDlets, and once you install them, you can work with those methods. And of course, it's a best practice to use the reference documentation of PowerShell or REST API, depending on which of these tools for automation you're using, because those are products that are going to have new packages enabled. There will be new things coming through, and as you cannot remember everything by heart, it's always recommended to have the documentation as a reference in front of you when you're working with this stuff. On this slide, we're demonstrating how easily you can test your REST API calls. As you can see here, we're using this invoke Power BI REST method to call the REST API without the extra overhead to make some Azure Active Directory authentication. So it's pretty straightforward. And when you are working with REST API, that can be really handy because you do not have to have that huge overhead. If you are more on the administrator type of tasks, you might want to actually do different administrative tasks also in a more automated way. And you can, for example, list the contents, you can connect to your workspace, do your workspace management, find data sets or for that given data set. So all of these administrative tasks can be also scripted and they can be reused later on, and you do not really need to do them manually every time. This is Module 7, Part 2 demo. And in Module 7, we were discussing the difference between My Workspace and the difference between shared workspaces, how we can use collaboration between different stakeholders who are participating in creation of our reports. So here, as you can see, on my screen, we're connected to my Power BI service where I'm viewing currently my workspace. And as you can see in my workspace, I have a couple of artifacts that are created. So for example, I have this contours of vehicle anomalies, which is a dashboard. We have a report that is called contours of vehicle anomalies as well, and we have some report that is a test report that I used for testing purposes that is called test usage metrics. And by the way, as a little refresher, the main difference between dashboards and reports is that with a dashboard you can stack items, you can pin items, visualizations that are coming from different reports, whereas with the reports they are coming from the same place. So let's have a look at this report. As you can see, that's the report that we saw in the previous module, which is using basically this contours of vehicle anomalies data, where we display the map of United States with the different vehicles that are having some anomalies, and we have some extra visualizations. As you remember, it is discouraged, and you should never use the reports within your personal workspace. When it says my workspace here, you should not be using them for sharing purposes. This is only for your personal usage, to explore them, etc. Another aspect that we discussed in Module 7 was that share button. So with this share button, you could share that across your organization, this report, and you can also use this report exportation in different formats in order to physically share that with some other stakeholders. Now let's have a look at the shared workspaces in Power BI. And as you can see here, we have this DP-500 Labs type of workspace, in which I have also different artifacts. Now within this workspace, I have some dashboards, reports, workbooks, etc., and data sets even. And in the same way, we can modify them, work on them, but the difference is that with this shared workspace, other users, other report developers will also be able to work on them and modify the artifacts. So whenever, for example, I leave on vacation, my colleagues will still continue to be able to work on those reports. We also spoke about data flows, and actually within the Power BI service, you can create them here in this data sets and data flows section. And as you can see here, I have a couple of data sets here, but I do not have any data flows. So we can click on this new button in order to create a new data flow. And as a little reminder, the data flows are simply, they can be thought of as tables, which are representing your data with rows and columns, and you can create them using define new tables feature, link tables from other data flows, and all these options are here because some of the options are Power BI premium options, and as you might have noticed from the previous page, my Power BI is in a premium capacity. That's why I have all the possible options in here. So I will click on this add new tables. And when you click on that, you will need to first specify to which data source you want to connect in order to reproduce that ETL transformation logic. And you will need to set up a connection. For example, if I wanted to configure this Azure Blob Storage account connection, I would need to specify the account name or the URL. And for that, you need to have an Azure Data Lake storage or Azure storage account behind the scenes for your Blob storage in order to provide here the URL that will let you connect to that storage account. You will need to create a connection. So there's quite some configurations that we will need to set up behind the scenes before we can create our data flow. We will need to specify if we have a data gateway, what type of authentication we're using, and depending on the type of data source to which we are trying to connect in order to reproduce that logic in our Power BI, ETL logic in our Power BI using the data flows, we will be able to select different connection types depending on the data source to which we're connecting. So for example, for blob storage, that will be anonymous, account key, or shared access signature. And just a little hint here, shared access signature is always a better choice because it's more secure, and you can specify in a more granular manner what type of IP addresses you want to restrict from that shared access signature, what's the duration for that SAS string, etc. The anonymous should not be used in actual production environments. So that was demo for Module 7. I hope you enjoyed it. With that, we have reached the end of Module 7 Part 2, and we are going to be seeing each other in the knowledge check. This is the knowledge check for Module 7 Part 2. Are you ready? Question 1. which of the following is correct? Power BI Premium is all about A. Capacity or content, B. Number of users, and C. Dataset refreshes. And the correct answer is, of course, it's about capacity or content. Number of users is Power BI Premium per user capacity. Question 2. The ability to combine multiple data connections describes which data connectivity mode? Live or exploration, direct query, or composite? And that's right. The right answer is composite, as the name suggests, and as you might remember from the module. Question 3. Which of the following embed scenario allows you to easily embed interactive Power BI content in blog posts, websites, emails, or social media? Publish to web, embed in Power Apps, or SharePoint Online Web part? And of course, the right option is the Publish to Web button, Publish to Web option. And with that, we have reached the end of our Module 7, Part 2. I'll see you in the next modules. Hello everyone, and welcome to Microsoft's Designing and Implementing Enterprise-Scale Analytics Solutions using Microsoft Azure and Microsoft Power BI. My name is Anna, and this is DP-500, Module 8, where we will be speaking about managing the analytics development lifecycle. Let's have a look at the module agenda. In Lesson 1, we will be talking about designing a Power BI application lifecycle management strategy. And before doing so, we will understand what is the ALM, or the Application Lifecycle Management Strategy in general. And then we will be talking about that strategy inside Power BI and what are the different tools and aspects of Power BI configurations that you can leverage in order to configure the lifecycle management of a Power BI project. In Lesson 2, we will speak about creating and managing a Power BI deployment pipeline, which is a part of our CI/CD process within Power BI, and we will understand how that works and how that will simplify the work that a data analyst and a report creator is making inside Power BI. And finally, in Lesson 3, we will be talking about creating and managing Power BI assets, and we are going to be seeing all the different aspects of the Power BI configurations and best practices that we recommend using to manage our Power BI assets. So let's get started with Lesson 1, Design a Power BI Application Lifecycle Management Strategy. And with ALM, as you might already know, especially if you are coming from some development background, you might know that any development project will have different phases, and we will need to provide some kind of mechanism behind the scenes that will provide us the continuity of the development process, writing the code, of testing, then sending that product into production, so publishing the product. And finally, this is a life cycle, so which means that we will then be collecting some feedback. Our product is a living product which will be having its own life cycle, and we will be then modifying it and redeploying it again once it has been again developed and tested. So this CI/CD, continuous integration and continuous delivery portions of any development project are also applicable to Power BI, because even if Power BI projects that we're working on creating reports is not really writing code, but still those projects will be facing different phases, especially when we're talking on an enterprise scale. We will be having multiple contributors to our reports, multiple teams and team members, data analysts that are going to work on those reports, and we will need to make sure that the continuous integration of those reports, testing, passing those reports and dashboards from one phase to another will be continuously managed, and we will not have to rewrite the full report once a colleague of ours accidentally removes it or once somebody does a modification. Within the continuous integration, we will have also the portion of things where we need to understand what were the modifications that were applied to our product, to our project. So in our example, since we're talking about Power BI reports, we might want to know what visuals were added, what different modifications have been made to our report itself. In a development project, it's more of a binary files because we are dealing with code, so we will be more comparing the text. And this brings us to the conclusion that when we are working with the different development projects, the CI/CD pipelines, the CI/CD continuity will be provided using tools like GitHub. Some of the other developers will be using DevOps or any other products that allow us modifying the code in a collaborative environment, viewing who did what type of modification. And depending on the product, those tools can be different. Now, in Power BI, you can still leverage GitHub, for example, but we will see in later slides what will be those differences, substantial ones, that are related to the fact that we are no longer coding, we don't have any code, but we are mostly working in reporting environment in PBIX files. So, among the tools that we will be looking into, those will be OneDrive, SharePoint, and we will see which tools are better suited for Power BI project lifecycle management and in which cases you should leverage them. So let's first have a look into what is an application lifecycle management, or the ALM. And of course, it will have some elements of governance. Those could be system administration tasks, for example, tracking our changes that we are bringing to our files and code, data security, different policies. We will have the development aspect, where we identify what are the problems, what problem we're trying to solve with our code or with our file that we're developing with our report. And then we will be having the maintenance phase, where we will need to get some feedback from the users. We will need to make sure that the product is compliant to the original requirements. And then this is going to be a continuous loop where we will be again redeveloping or modifying some parts of our product, and again putting it into test and deployment phases. On the right-hand side of this slide, we have the demonstration of this application lifecycle management in a more generic term, not referring necessarily to Power BI. But we will see later on that in Power BI as well, that will be quite similar. So first, we always need to start with planning and tracking. We need to understand what type of issue we're trying to solve, what we are trying to bring with the solution that we're creating, and then we need to start the development. Then this will be followed by building and testing phase, where testing teams will be trying to make some tests in order to see if the product is handling the charge, if the product is working well, if there are no bugs, etc. Then we will go into the deployment phase, where we are deploying our product, our code, our Power BI report into production environments, and then it needs to operate. While it is operated, we need to monitor and learn. On one side, we need to monitor whether the production environment is handling the charge, whether the product, be it our Power BI report, be it our application that we created using code, is it handling that charge? Is it buggy? Are there any inconsistencies? And also, we need to learn the feedback from our users. Those could be report consumers if we are talking about Power BI, or those could be some users of our application if that's an application that we developed using code. And finally, this will be feed-forwarded into this plan and track phase, and this is a continuous life cycle. Now, when we are working with Power BI, we will be working with different aspects of development of a Power BI project. We will need to work with data set development and testing, where we will be connecting first of all to our data source, ingesting that data or connecting to that directly, creating data sets, creating our DAX expressions, creating calculation groups, and all that stuff is also part of our development of Power BI project and Power BI report later on. With the CI/CD pipelines within Power BI, we can use that portion of things. So, for example, here we have DevOps as an example. We can use that for data engineering tasks. So this is more of a data engineering ETL transformation loop that is going to be managed by data engineers and not necessarily enterprise data analysts or data analysts in general, but there will be always an input and collaboration between data analysts or enterprise data analysts and the data engineering teams, because data engineers need to know what is the final goal of this solution that is going to be developed, so that the supporting data warehouse behind the scenes and the solution is going to be respecting those prerequisites. And the final part of Power BI development and lifecycle management project, of course, is going to be creating our reports, workspaces, managing the different apps and different artifacts from within our Power BI environment. And for that phase, again, we can have these different phases. So as you can notice from the slide, we tried to group those different phases of a Power BI typical project, where we first start with data set development, ingestion development, then we also do some data engineering tasks on that data sets, and finally we create the reports. And in each of those phases, we can still need this CI/CD continuity, CI/CD pipelines. Those might not be necessarily DevOps or GitHub pipelines. In all of the cases, we will be mixing and matching depending on what type of files and projects we're working with. For example, here on the left-hand side, we see for the dataset development, you would typically use either the Visual Studio Code or the tabular editor. And when you are developing your model or your data sets, you will be mostly using you could use tools like GitHub, for example, because for BIM files, it will be easy to follow, to track what has been changed in those files. But if we work, let's say, with PBIX files, we cannot really track that with GitHub. And it's not only the fact that some of the users might not be familiar with GitHub, and they might be more familiar with tools like SharePoint or OneDrive, but it's also the fact that it's not really suited for that kind of file tracking, CI/CD tracking. For data engineering tasks, we could, let's say, use DevOps, and the CI/CD lifecycle will be managed with DevOps type of tools, which are really suited for those tasks. Now, for our reporting phase, which will be the development of our reports, and we might have multiple stakeholders, multiple data analysts or report creators that are collaborating and working on the same report, on the same workspace, and we might want to share that workspace. We might want to make sure that other users know what we are doing in that workspace, what changes have been done before the testing phase, so in the development phase, or once we deployed it, what has been changed. Have there been any artifacts like reports being added in the testing phase, for example? Have there been any things that have been removed? And for this portion, which says here Power BI deployment pipelines, we can use the Power BI service itself, where we can create those pipelines. And as you can see here on the screenshot, we're displaying here how we can move our workspace, our artifacts, those could be data sets, reports, dashboards, from one phase to another, from development into test, and from test to production. And we can actually, if let's say I have a report or a workspace, and I want to make sure that other stakeholders, other report developers know that that specific workspace is currently in its development phase or in testing phase, I could assign that phase directly. I don't need to first go by the development phase and then go into test. I could have directly assigned the testing phase. Now let's have a look at the different tools that we can use for our source control strategy, and what are the best practices depending on the type of source files that you are working with. So when we are working with the Power BI service workspace, we shouldn't be using the source control that is available within the Power BI service for PBIX files. And why is that? Well, because those are files which are not really suited for the deployment pipelines, for the CI/CD pipelines inside the service. For those kind of files, it's better to use OneDrive or SharePoint. In addition to that, most typically within an enterprise, the stakeholders, data analysts, enterprise data analysts, and all those report creators are going to be quite frequently more familiar with tools like OneDrive and SharePoint. And those tools don't need any extra development capabilities. You don't need to be familiar with the Git environment to be able to share those files. And it's really easy folder type of structure, and you can really easily share those files and visualize what has been changed from one version to another. So you can deploy that CI/CD portion of things for PBIX files using OneDrive and SharePoint. If you are, on the other hand, working with BIM files, let's say you are developing your tabular model in Tabular Editor, and you are using BIM files, then you can track using GitHub or Git repositories. You can track the changes and the CI/CD continuity using GitHub. And usually tools like GitHub and DevOps, those are tools that are more suited for developer profiles because they are usually familiar with those kind of tools. And it has the push and pull functionality that will let us copy the data and then push it back once we have modified it, and it will have also some mechanisms to provide understanding what has been changed in the file compared to the previous version. We will be able to see that visually, and that's a very interesting mechanism for development type of projects. And for Beam files within a Power BI project, we can use the Git type of integration. Now, for the deployment strategy from Power BI service, when we are already in the reporting phase, we will be using the CI/CD pipelines as the ones that we're displaying here on the screenshot. And on the very first side of the screenshot, on the left-hand side, you will see that we have one artifact that is available that is called Human Resources Sample that is currently in the development phase. And you can see here that we can publish that into deployment, we can deploy that into test phase. And the one that we see next, we can see that it's there is an extra artifact that has been added. It's a Power BI report, which was not present in the development. As you can see, we have only Human Resource Sample here. We do not have the Power BI report. And we can publish this specific phase into production. And as you can see, also visually, we can see what are the differences between those two phases. So we can see that there is something that has changed, and there is something that wasn't present. You can see that with this yellow not equal different sign, not equal 1, there is only one single difference that has been found between these two phases. And there is something that didn't exist, which is this red -1. So this is the artifact that didn't exist before. And when we deploy that to production, we will have our Human Resources Sample that will be published inside our production environment. Now let's speak a little bit about creating and managing a Power BI deployment pipeline in a bit of more details by first understanding what are the different stakeholders that will be working in that collaborative environment. And then we will understand how to work with those different aspects. So first, as you can see here on the slide, we have our developer or creator that will be involved in all the different phases of development, testing, and production. But on the other hand, we will have different stakeholders that will be involved in each of these phases respectively. So for example, for the development, we might be working with other developers and creators. For the testing phase, we might be working with other developers that will be helping us out in testing our solution and other creators. And for every phase, we need to ask ourselves, we need to collaborate with those teams and make sure that the project is ready to be deployed to the next phase. It needs to be reviewed, tested, and once it's ready, we are pushing it to the next phase. In the final phase, which is the production, we will need to have the feedback and the help of the business users, which will be using the already deployed product and feeding us back with some information about how the reports are doing. Are they good enough? Are they fast enough? Are they really answering the questions that we were looking to answer and the problems that we're looking to resolve using the Power BI reports? And this will be, again, these different phases will be in a continuous CI/CD deployment loop. So when we work with deployment pipelines and with any Power BI project, the best practice, of course, is to always start with choosing the right model framework. And although this sounds not like a surprise, but in general, this will impact a lot the performance of our reports and the whole optimality of our solution. So we need to first model our data sets, our tabular model in the correct way, connectivity mode, properly design the connectivity modes depending on the sources. Are we using any gateway? So all those different aspects that we will have been learning about all along these modules, we will need to take them into account and plan accordingly. In order to avoid any reports being too slow, we might want to make sure that we're designing properly the relationships between our tables within the models, the filter propagation, and of course when we're ingesting data or when we're connecting to a data source, try to transform the data as close to the source as possible. And that usually means that we should do the data transformation using some data engineering practices directly inside the source before bringing it into Power BI. So once that phase is ensured and working correctly, so we have our reports to be done, we can use our CI/CD pipelines within Power BI service, as you can see here on the slide, in order to create our deployment pipelines. And as you can see here on the left-hand side, we're demonstrating the fact that you can create a deployment pipeline by using one of these menu options on the left-hand side. There is a hub that is called Deployment Pipelines, and when you click on that, you can actually create a new pipeline from this canvas, which is opened in the main portion of the page. You will simply click on creating a new pipeline. Another way to create that, and as you might already know, for most of the tools that we're working with, there are multiple ways to do the same configuration, multiple places where you can find some buttons. Same for the deployment pipelines. You can use this Create Pipeline button that you can see directly from your Power BI service environment, directly going into that CI/CD creation from here. When we are working with workspaces in Power BI service, we can actually assign that workspace to any of the phases. So we do not have to start by the development phase, but here on the slide, the example that we're demonstrating, we can see that we're starting from the development phase, and here we have our sales and marketing that is assigned to the development phase, which we can then later on deploy into our testing phase and finally into production. And we can see what are the data sets in this data sets or data flows also that are associated into those artifacts that are published from one phase to another. As you can see, we do not have any in this specific example on the slide. So we can compare visually the stages between the reports and artifacts that were in workspaces that were publishing from one phase to another. As you can see here, we see that we have one data flow in this phase, 2 data sets, we have 4 reports and 2 dashboards. And we can see for each of the artifacts in the following list that we see below, we can see what are the different changes that have been brought to each of those artifacts, data sets, reports, etc. And then we can decide whether we want to deploy it like that or we want to give some more modifications into any of those artifacts before we go into the next stage. Now let's talk a little bit about creating and managing our Power BI assets. And in general, when we speak about creating reusable Power BI assets, we will first always start by creating a discipline and enabling the flexibility, making sure that our assets are being reusable. And when we speak about assets in this specific context of this module, we're referring to data sets, to reports, to workspaces, and we need to make sure that, for example, for our data source, we need to have a single source of truth, single master data source, as we see on the slide here. We need to make sure that all the data sets are created specially for our Power BI reports, considering all those prerequisites that we will need to have: the charge, the flexibility, the storage modes, and all those different relationships inside the Power BI tabular model in order to make sure that our DAX expressions and the filters within those expressions are propagating in a fluid manner without any delays. And finally, another aspect of our Power BI environment, once we have created our data sets, we might want to promote them. Because when we are speaking on an enterprise scale level, you might connect to your Power BI service and you might see lots of data sets. And you might not really know with which ones you should start, especially if you are just starting with report creation, you are just starting your data analysis at scale, you might not know which ones should be used. And actually in Power BI service, you can promote some of the data sets so that they are used more as in a priority than the others. Another interesting aspect that you can investigate from the Power BI service, that's the assets, what changes are your assets facing, what is the lineage, the end-to-end lineage of your assets that you have in Power BI. And as you might remember from one of the previous modules that we have seen earlier in this course, we have been speaking about lineage, but more on an enterprise level, which means that we could see the full landscape, the full data map in Microsoft Purview for our data assets. Now in Power BI it's slightly different. As you might guess, from Power BI we're speaking about the Power BI service interface, from where you can see only the lineage view for the artifacts that are being used for your Power BI reporting. And this is what we also face on this slide. As you can see, we have the same SQL Server, which is in the cloud, that is used for different reports. And we can see that Region 1 report is completely developed in Power BI Desktop. We're directly using that data set inside our report that is called Region 1 report. And we have the same database that is used for our core data set, and we're using later on this data set for different other reports within our Power BI. So this is more of a lineage of our artifacts within Power BI, and that's the major difference between Microsoft Purview data lineage and Power BI asset lineage that we can see from the Power BI service. And usually when you are data analyst, you might be only working with Power BI service and you might not be really having access to Microsoft Purview. So this can be handy. And finally, when you need to enhance your solution with some extra functionalities, when you need to work with your data sets on the backbone, from the backbone of your Power BI service, you might be enabling the XMLA read and write endpoint in order to have a bit more control. By default, it's only the read-only feature that is activated, and read-write can be enabled only for special cases when you need to manage the data sets and when you need to do some extra development for those extra development purposes. You might be using the XMLA endpoint. This is demo for Module 8, where we learned how to manage the analytics development lifecycle. And as you remember, we were talking about deployment pipelines for our workspaces and other artifacts that we can create from Power BI service. And the deployment pipelines will enable our stakeholders to work in a collaborative manner on those different components and see what are the different current stages or phases of our deployment. Is it in development, test, etc. phases? So what we see on my screen currently, that's my Power BI service, and I'm currently in this section that is called Deployment Pipelines. As you can see, I already have one deployment test pipeline that has been created. It's called Test CI/CD. And if we go into that Test CI/CD pipeline, we can see that I just finished a deployment, which I ran right before we started, so that we can have a look at the currently deployed item. And what we observe on this current deployment pipeline within the Power BI environment, we see that we have development, test, and production phases. So those are the different phases of our artifacts that they can pass through. So in the development phase, if I click on this Show More button, I can see that I do have within this DP-500 Labs Power BI shared workspace that I have created beforehand, which is in a premium per user capacity. I can see here the different artifacts that are associated with my DP-500 Labs workspace and are currently in development phase. So if a colleague of mine, another data analyst, report developer, will be connected to their environment of Power BI service within the same tenant, they will see that this specific artifact, the sales analysis, has been in this development phase. They can see some history about that. They can compare the two phases to each other, as we saw earlier from the slides in that module. And as you can see, when I click on that compare button, I can see which of the artifacts have changed or have been modified in between these two phases. So we have development and test phases in this example, and we can see that there are two things that are not the same ones, so they have been modified, and we have some extra thing that that is not here in the test phase. Another thing that we observe here is that we have this yellow deploy button where we will be able to specify selectively, say which of the artifacts we want to deploy to the next phase. So for example, we can click on this customer profitability sample and click on the deploy button. We can even add a note so that my colleagues will know why I'm deploying this. So I made some changes and deploy that. So when we click on that button, we will be starting to deploy, and in here we will see with this little notification on the top right hand side that the deployment has been completed to the next phase. So when I click on this show more, I will see that there is this copy of this specific artifact that has been deployed twice to the same workspace. On the top right-hand side of my workspace here, of the deployment pipelines, we can click on the deployment history and we can see the users who have been deploying the different artifacts to my workspace and to which phases. So we see that we deployed, I deployed a couple of things to the test phase of my CI/CD pipelines. We can also get more information on which items were deployed. So I will click on these items and we see that there is a difference between the items that were deployed. Here we see that there were some new items that were added, and you can see that this is the sales analysis in force model security data set. And when we click on this item in here, we can see that we have two new items that have been also deployed from development into test phase by this user, and we see more history. We can also do some filtering in here, test and production, but we do not have anything in production because for now I have not yet deployed anything to the production environment. So let's say if we select this report and we feel that it's ready to be deployed to the production, we will click on this deploy button. We will deploy that in here, and in the production portion of my CI/CD deployment pipelines, we will see that report appearing, and all the stakeholders that are having access to this environment, to this Power BI service with this pipelines, they will be able to see that this specific report is currently in production phase. And when we click on that report, we will see what we have in there. We can also edit that if necessary and redeploy later on. So that's the demo for Module 8. I hope you enjoyed it. So with that, we have reached the end of our Module 8, and we will see you in the knowledge check questions. This is the knowledge check for Module 8 for the DP-500 course. Are you ready? Question 1. For application lifecycle management, what is the process called for automating code deployment from development to production? Constant update, constant deployment, continuous integration, continuous delivery, continuous update, continuous development. That's correct. It's the CI/CD abbreviation opens up as continuous integration and continuous delivery. Within the integration, remember that we had the development phases of our project, and delivery is the continuous deployment and delivery of our services and project. Question 2. Which of the following is a key benefit of deployment pipelines? Dataset creation is streamlined. Reports can be published from multiple workspace environments, or less manual work and fewer errors. That's right. The correct answer is less manual work and fewer errors, because we will be actually automating that CI/CD work with the pipelines. Question 3. What features must be enabled for you to manage Power BI datasets from external tools? Power BI Service API, read-write XMLA endpoint, or read-only XMLA endpoint? And the correct answer is read-write XMLA endpoint. That's the one that we will use for managing anything from the backbone of Power BI and connecting from external tools to Power BI datasets. And with that, we have reached the end of our knowledge check for Module 8. I hope you enjoyed it. We have reached the end of this session, and in this course, DP-500, we have spoken about different technologies that enable enterprise-scale data analysts create their tabular model inside Power BI, leverage tools such as Azure Synapse Analytics, and any other tools that will enable us in creating the data warehouse behind the scenes that will be used and supporting our data analysis inside Power BI and the creation of the enterprise-level reporting. In the first modules, we have gotten also introduced into Microsoft Purview, which is a product which will let us govern our data across enterprise and have the full landscape overview of our data map across an enterprise. And that's something that can be used by data analysts on an enterprise scale to understand where the data is coming from, to collaborate with different teams such as data engineers, data scientists, and use those data sources by understanding where they are coming from. We have also looked into Azure Synapse Analytics in more details, where we have learned how to leverage the different clusters, or more specifically, serverless SQL pools, dedicated SQL pools, Apache Spark pools, in order to create and to work with our data sets, to create our data sets that are more fitted for Power BI in order to import them inside Power BI later on. We learned how to create a data warehouse in the cloud. We have looked into physical data warehouse, logical data warehouse using the serverless SQL pools. We have looked into transforming our files such as Parquet files, CSV files using Apache Spark pools. We then moved on into understanding how we should build our tabular model in Power BI, where in lessons, in modules 4 and 5, we have been speaking about how to optimize our tabular model, why we should use the star schema design, why we should be using the different relationships and the filter propagation paths. What are the best options to use the storage modes in Power BI depending on the data source that you are working with. We have also spoken about functions that are enabling us using some of the filter propagation paths, or on the contrary, not using them, such as DAX functions that we touched on. We spoke about calculate function in terms of the DAX functions. We also looked into different security aspects of things, object level security, role level security, and all those different things that you can configure within your Power BI environment to improve your data model and to make sure that all the reports are being done in a secure way, so that only the stakeholders that are supposed to see those data sets will be having access to those lines of your table. We then moved into next modules, module 6, where we spoke about advanced data visualization techniques, where we understood how we can improve our visual appearance of reports to make them look more professional and more user-friendly, and also friendly to low-vision people, to make sure that our reports are color-blinded friendly as well. And we then looked into other features such as data flows, which will help us automate certain tasks in Power BI. We looked into things like how you can automate Power BI environment and provisioning of different resources within Power BI environment. We understood what are the different stakeholders within our Power BI ecosystem, the administrative tasks that usually a central IT role is dealing with. And with this last module, we concluded by understanding how you can use your reports within a CI/CD loop by using the deployment pipelines functionality. And with that, we concluded our course on DP-500, designing and implementing enterprise-scale analytics solution using Microsoft Azure and Microsoft Power BI.